There it goes. I was able to push it, Tyler. You should get the link.
Oh, cool.
So we have people coming in. That we do. Hi, hey, hello, everybody. Thanks for joining us.
Hello, hello.
Yes, I know this meeting is being transcribed. Leave me alone, Zoom. So, yeah. Well, thanks for coming to hang out with us on this awesome Wednesday, everyone. We had promised this workshop would come back around, and here it is. Hopefully, it actually works. So we'll give it a minute to let everybody get in and before we kick it off. If you have received an email, it would have came from a no reply at Rackspace that has the link for you to access the lab. Once you get in, as we get started on the slides, go ahead and click that link to open it up so it can start spinning up your lab environment. If anyone's having any issues with the your lab environment not working or you didn't get your link, go ahead and shoot us a message in QRA or PME in chat, and we'll make sure we get you taken care of. So I'd say we can give it to, let's say at 5 after Tyler, then kick it off.
Sounds good to me.
For those of you already in the room here waiting for this to kick off, has anyone not received an email with the lab link yet? So there are a number of labs. Which one should I enroll in? You shouldn't have to enroll. If you go to your enrolled tab, you should see hunting through the SIEM or PTW-hunting. That is the current lab for today. If you are,
say
go
it
ahead, Tyler.
should say enrolled next to it. It'll go back to that page if it times out after inactivity, so it could have just defaulted to that one. And yes, it is totally fine to have a basic understanding of the SIEM. We're not going to go over any kind of crazy concepts. This is kind of like not quite a 101, but this will be a more of a basic level, kind of teetering on that intermediate level. So any kind of SIEM experience you have, or no SIEM experience at all, is fine as well. Ooh, coming from Elasticsearch, oof, that's got to be rough.
This will be easier. So I actually just taught something surrounding that last week around Elasticsearch, and it is definitely a learning curve going back to that query syntax compared to Splunk. So this will be a cool introduction to Splunk as a SIEM if you've never used it before. You'll get some interesting tips, tricks, tidbits about threat hunting, utilizing a SIEM and other tools like Sysmon effectively. Tyler's got something pretty cool built for you guys. I think you'll have fun.
Yeah, looking forward to it. And then Aaliyah, for the lab, you should have received an email probably just a few minutes ago from Rackspace. That'll have your lab link in there for you to just click on. It'll send you into the lab environment.
If you don't have that link, let me know. I will get you set up.
Yeah, we have a bunch of extra lab entitlements set up. So if you don't have one, or your lab has lots of errors for whatever reason, maybe it got messed up while it was being stood up, we can shoot you another entitlement and get you set on that one. So if you have any issues with the labs, it can take up to 10 minutes to load. So just give it a little bit of time. We won't be jumping into the labs until a little bit later. I'm going to go over some basic stuff first. I'm already getting ahead of myself. But yeah, if you have any issues with the labs or don't have the link, please just let us know. We can shoot you out another one. All right. Yeah, Trey, looks like Aaliyah, hopefully I'm pronouncing that right. Looks like Aaliyah doesn't have one. If you could shoot her over one, shoot them
Yep.
over one. Thank you.
Yep, I'm on it.
All right. Well, that takes us to just 5 after. So we'll go ahead. Anyone else who's going to join, we'll let them just roll in, but figure we might as well go ahead and get started. So hello, everybody. Thank you for joining. I'm very excited to do this course. Hunting through the SIEM is one of my favorite things. I think it is a lot of fun. Um, so I am excited to get this course started and get us rolling. So with that, hello, I am Tyler Casey. I have about 10 years of experience. I guess I made this slide like a year ago, so let's say 11 years of experience doing DCO, which is defensive cyber operations. Currently, I run the blue or defensive side of our purple team engagements that we put on here in Scythe, as well as creating a lot of the threat emulations that we put out every month. Um, and then before I came to Scythe, I was on a CPT, which is a cyber protection team, where we deployed internationally for incident response and targeted threat hunting. And I have my socials available on that page if anybody wants to link up and connect.
Hey everybody, I am Trey. If you've not seen this awesome face before, I am the lead here with Scythe Labs, and I am the red side to our purple team. All of the content and typical things you see coming out from us, that is me and Tyler and our team here. In a previous life, I've done a bunch of different things. Primarily came out of the DoD as well. That's where me and Tyler met. We worked on teams together. I've done red teaming. We've done a lot of blue teaming, infrastructure work, threat hunting. We've played SOC analyst games for a while. I'm a formal educator and content creator. And if you like alphabet soup or are curious, I have some of them listed there on the slide, as well as at my socials that you can find. So I'm kind of here to back up Tyler today and make sure this goes smoothly and handle any issues you guys might have.
For sure. Let's get into it. All right. So again, if you have gotten the lab entitlement, please start it now because it can take a little while for the labs to load. If you don't have them, just throw it in the chat or in QA, and Trey will shoot you another link. No, Trey and I are not siblings, but we have been friends for a long time, and kind of like brothers out here. But no, we are not siblings.
So our wives would think we are, but
Yes,
no,
yes.
we're not blood. We're family. There's a
Yeah.
difference.
For sure. So yeah, go ahead and start that entitlement link. Again, any issues, please let us know sooner rather than later so we can get you started on a new one. Like I said, they could take a few minutes to stand up. Alrighty, so to get into it, today we will be talking about hunting through the SIEM, the methodologies and the iterative process of it. We're going to go over Splunk in general, some Splunk queries and functionality. We're going to deploy some threats via Scythe that we're then going to hunt on for adversarial behaviors. And then to wrap it up, I'm going to give you some documentation or some ways to document and some ways to report or some ways to create reports of your findings as well. So kind of a holistic hunt, start to end of getting in the SIEM, going through the logs, finding the bad guy, investigating, pivoting off what we see, and then going into the reporting in the end. Oh, before we get into it, see the question on which machine to start first. If it loads up, you should be on the unicorn box. For some reason, it's starting people on different consoles that they're not supposed to start on. I'm not sure why it's doing that. So, but if you go to consoles in the top right of the lab page, you should see unicorn on there. Just click on that one. That's where we'll be at, I think, for the entire lab. I don't think we'll even be jumping into any of the other servers. Sorry, everybody. I'm on some new meds right now, and my mouth is very dry, so I'll be taking lots of breaks. So first up, threat hunting 101. Is anyone here familiar with threat hunting or has performed some kind of threat hunting in the past? All right, got some yes. Okay, cool. So everybody is kind of familiar with it. It seems like we're all kind of at the same level of it, which is great. Like, so we're not going to get into anything too crazy. So any level that you have of it is totally fine. So I was just curious if anybody has had some use of it in the past. So with that, what is threat hunting? Threat hunting at the most basic level is just actively looking for the bad guy, actively looking for malicious activity or anomalous indicators, things like that. There are two main approaches to threat hunting. That is reactive and proactive. Reactive is when you get an alert or an anomaly is detected by some kind of automated system or something like that, your EDR goes off saying that Mimikatz has been installed or a virus has been executed, something like that. That's reactive. So you get an alert and then you go into threat hunting or incident response mode and kind of go through and try to identify what all is happening, right? And then the other side of that is proactive, which is a hypothesis-driven hunting looking for unknown or stealthy threats. And proactive threat hunting does not mean that you will detect malicious activity every time you perform it. In fact, most of the time, you won't find any malicious activity. Why? Because you can't detect what isn't there. Doing a proactive threat hunt, you're going off of CTI, you're going off of things you're curious in to hunt and see. You're going off of your most likely or most dangerous courses of actions that you're concerned with. You're not receiving an alert where you know something bad has happened or you're tipped off to something bad happening. You're going in proactively without any alerts or anything like that to try to find the adversary. Excuse me. So sure, that sounds kind of counterproductive to what we're talking about here because we say that proactive is the best type of threat hunting. But by proactively threat hunting, you are forced to immerse yourself in your environment and your network. It's going to force you to you're going to create a mental image of what activity is standard or baseline in your network or environment. You'll be able to identify what machines are commonly on your network, what common processes or scripts that run all the time, what services are common or are installed, scheduled tasks, common software, standard kind of intranet or internet activity. And while all this might not be malicious activity, it will help you to identify activities that are not best practice as well, such as SMB connections out to the internet or RDP connections out to the internet. It will help you kind of see any kind of workarounds that might exist on your network, like shadow IT. You have people that think they know better than the IT or than the whatever cyber cells you guys have there. So maybe they're putting in some network proxy configurations or installing unintended software like Steam. See that all the time. People will try to download video games onto their environment so they can play it while they're at work. So really proactive threat hunting, in addition to all the benefits we're going to talk about here in a minute, it's just a great way to kind of get into your environment and get a better understanding of what's normal. So by knowing what is normal, it will really help you identify what is anomalous. Because when you first look at a network and you have all these logs, all this activity, everything looks bad, right? There was some tweet I saw that said the best administrator script looks like an adversarial script because it runs all the time. It's running from weird users in weird places. It has variables, things like that. So the more you know about your environment, the easier it will be to identify malicious or anomalous activity, and proactive threat hunting helps you with that.
Yeah, and overall, it makes just incident response, God forbid you have to get there, that much easier. Is how do you determine if a host is supposed to belong in the environment or not if you don't know? So by doing this proactive kind of process, you're able to easily identify common hosts, build out an actual asset inventory so you know what hardware software you have, and it's going to stand out that much quicker. So your ability to recognize it and take action is going to be expedited.
Yeah, for sure. So when I was on the threat hunting team, we would deploy to organizations that were not our organization or our network. And the first day we would have 50 questions about what is this script that's running on startup? What is this registry key? Who is this user? Should they be connecting to this or that? And a lot of it can be explained away. So by proactively threat hunting, you're able to kind of answer these questions as you go and proactively have the answers to them before an incident happens and you're not sure what's normal and what isn't normal. All right. So what is the importance of threat hunting? And this applies to both reactive and proactive threat hunting. So threat hunting is human driven. Defender interaction and analysis will reduce the reliance on defensive tooling for alerting. It's been proven, and we see it all the time, that these tools that we have, the EDR solutions we have, are not just magical protection buttons. You can't just install them and hope that everything is fine, or you can't just install them and be like, okay, we're good, we're safe. There's no way we'll be affected by this. These tools and things that we utilize are good, but they're not perfect. At the end of it, they're just kind of tools, right? You need to be able to use them properly, but it's not going to catch everything. So it's up to you to be able to find and identify and determine what is malicious or anomalous, not solely on the tool. Obviously, you want to use those as a reference, but it's not completely on the tool. It will miss things. That's why companies are still hacked. That's why there's still breaches and things like that. So we need to be proactive, human driven, find the bad guy in the absence of any kind of automated tooling, right? And then the next part is reduced impact in the event of an incident. If you are continually proactively threat hunting, you should identify anomalous or malicious behavior sooner rather than later, right? So earlier detection will allow you for a quicker response, which will potentially minimize the impact of a breach, or it will disrupt that threat's kill chain. So if you're able to catch that threat or that threat actor's campaign halfway through, like let's say right after discovery, before they get into lateral movement, and you can stop them there, they're not going to be able to run the rest of their campaign. You will have effectively shortened or disrupted what their campaign is going to be. Ideally, you'll be able to stop their final impact actions, right? The next part is that it will strengthen your incident response. So it will expedite the time spent looking for a problem and be able to validate if something is wrong or not. Again, this goes into knowing your environment, knowing what's normal. Knowing that will really help you in incident response because you're able to then exclude a lot of things and get rid of a lot of that noise, right? But the only way you're going to be able to do that is if you know what's on your environment and you know what's normal. Probably going to say that about 100 times. Then next part is that it will reduce dwell time. This is kind of similar to the reduced impact in the event of an incident. So the earlier you're able to detect something, that's less time the adversary will have to perform the malicious actions on your endpoint, right? Again, knowing what's normal, identifying things that are abnormal is going to be a big help. And then the last part of it is to fill gaps. So it'll help you to identify potential misconfigurations, gaps in protection, or what assumptions you have of your security posture. That kind of feeds into purple teaming as well, where when you threat hunt and if you expect to see something and you don't see it, you're able to identify a gap that can then be fixed while you're doing a proactive threat hunt. So if you do get sent into an incident response or something like that, you can fill that gap before that incident occurs, right? Because by then it's probably going to be too late. So again, threat hunting is just going to help us gain an understanding of the baseline in your environment, and it's going to make deviations stick out more. And it's human driven. It's not reliant on tools. So you should be able to go in there and get in, really use that defensive mindset, defensive brain to go in and find the adversary.
Yeah. And the big things here, takeaways, real quick, Tyler, is we're trying to reduce that impact on ourselves and our organizations, right? That we say it all the time. It's not a matter of if you get breached in today's day and age. It's a matter of when. So understanding what you're working with, what the environment looks like, and you as a defender actively being there in the organization, looking for bad, are going to be more likely to actually see something wrong than the typical org that's just waiting for the tool to give them a ticket. If there's no ticket, nothing bad's ever happening.
Mm,
We've seen that as a big problem, and that's something that's easily solved by having your people have these capabilities and be proactive in what they're doing, not just reactive and waiting for true impact to happen to the org.
for sure. And also with that, how you said like people are waiting for tickets to pop up or they're waiting for something, an alert to say that something's happened. We'll also see where they'll get that alert and they're not sure what to do outside of what that alert says, right? So threat hunting really will give you a holistic approach or a holistic kind of story of what is happening in your environment that is not just reliant on one tool or one alert telling you what happened, because oftentimes those will not be able to give you the full kill chain of the activities that are occurring. It will just give you alerts kind of as they see it. All right. And then for threat hunting methodologies, we break them down into three main categories: intel-based, behavioral-based, and entity-based. So intelligence-based, which we're going to go over an intelligence hunt here in a little bit, is when you utilize CTI or threat intelligence to guide your hunt. So an example of that is maybe your intelligence team or your local defenders see some CTI, some cyber threat intelligence that is reporting that a threat actor is actively attacking your industrial vertical. Maybe it's finance, manufacturing, something like that. And they want you to initiate a hunt to see if these procedures or TTPs are being utilized in your environment. So that's taking some kind of CTI, a report that is related to you or your industry, and sorry about that, going in a report related to you or your industry and going in and seeing if those TTPs that are observed in this report are also observed in your environment. Then the next one, behavioral based, is using anomalies to identify and hunt on potential threats. So maybe a new service is created on a user machine, or you've identified that only one endpoint has that service installed. That's going to be something that you're going to want to hunt on. Or a user says that their machine is acting strangely and they get a command prompt pop up every few seconds for a couple hours. That's something that can lead you into your hunt. That would be more of a reactive hunt, which is okay. But it's just, yeah, if odd things are happening or your users are writing into you saying that something strange is happening, your computer keeps restarting, this pop-up comes up, they have some weird notifications in their notification bar, that should kick off a threat hunt. Your Another point of that, your alerts don't have to just come from your EDR or defensive tooling. Your end users that are at the keyboard, they also kind of know what's normal. So if you get an alert or a ticket or like, hey, this is kind of weird on my machine, it should also be something that you kind of take heed of and initiate a threat hunt for. And then the next one is entity based. So this is more focused on just kind of keeping an extra close eye on critical systems or assets that are likely to be targets for an adversary. Those are typically things like domain controllers, file servers, maybe the CEO's endpoint or the CFO's endpoint, shared drives, things like that. Critical systems that have some juicy info in there, right? That an adversary would want to have, or that they want to have complete control over your network. Domain controllers and file servers, internet-facing web servers are typically pretty high-value targets to adversaries. Excuse me. All right, core principles. So threat hunting is an iterative process driven by hypothesis and facts, such as data we have from our logs or an alert that we get, something like that. So we're going to examine those against known TTPs from a likely or dangerous threat to our organization. And this should continually evolve and improve based off of your standard baseline activity and your threat hunting kind of acumen. So we're just going to go through, should be hypothesis driven, focused on facts, focusing on TTPs and procedures. Going to use those logs, that data that we have to iteratively, continually hunt through our environment. And as you continue to hunt, your hunch should improve both in your what detections you have, as well as kind of your speed into what's normal. The more you do it, the more you know, the quicker you'll be able to kind of go through it, or the quicker you will be able to point out, is this anomalous? Is this good activity, malicious activity, things like that.
So Tyler, we had a good question in chat where a question was asked is, could you help us? How can we identify the threat that already exists on compromised host? Is there any kind of automated way that we can identify that threat by running these pre-built detection rules? In chat,
Um,
I had answered and said, well, it kind of depends. There is no magic button,
yeah,
but we can pair a bunch of things together, like a lot of these principles and concepts you've been talking about already, paired with things like proper logging and correlation with the use of tools and applications like Sysmon and a SIEM, and bringing all of this together along with your human mind, the acumen, the knowledge, and the expertise that you would bring and your knowledge of the organization you're working in together could help spot and find that bad if there's already somebody cohabitating on those endpoints.
yeah, for sure. I say that's a hard one. I'm with you on that. That there, like we said, there isn't like a magical way to do it to find the bad guy, right? The EDRs and tools and things like that help. It's also difficult if, let's say you have a weak defensive stack now, and an adversary goes on. You have weak logging. You're not forwarding your logs to a SIEM or to a central repository of some kind. If they're already on there, it can be very difficult to find them after the fact. You might need a forensic team or something like that. You would need something to kind of tip you off. But the good part is if they are on your endpoints, eventually they're going to do additional actions onto it to try to reach what their impact is. So you should be able to identify them off of the future actions that they go through. Excuse me. And hunt for them that way, as well as say we have some pre-built detection rules. We're going to get into that in what we call our threat hunting Kickstarter here in a minute. We're going to get into where some of these pre-built detection rules exist. So you should be able to translate those into your SIEM language, into your query language, and hunt for them that way. But yeah, if they're already on your machine, you might not be able to find. They're already on your machine. It could be difficult to kind of go back and find how they did that based off of your logging and how long you keep logs and things like that. But when they perform future actions, you should be in a good spot to detect those, and then maybe from that you can work your way backwards.
Yeah, and there's a lot of different things that could potentially happen that would cause them to trip up and show their hand so that you would see and know they're there. But we live in a day and age where a lot of times you see people using this whole concept of living off the land, which makes it extremely difficult to notice bad because in theory, everything there is allowed to be there. There's nothing bad happening from a first look. So it's a lot of context and like areas of gray when it comes to modern day threat hunting. I would say there's no one thing that can be the solution for you.
Yeah, I think too, as far as threat hunting and anomalous behavior, if you see something like a service or a local user account or a scheduled task or something like that that only exists on a few machines, or software that only exists on a few machines, that can also be indicative of some kind of malicious activity. So like if they had a phishing attempt that caught one user's box, they went on that box, they downloaded AnyDesk. We see that all the time, right? They download AnyDesk, they make a scheduled task or modify the run key. If you see that those procedures only exist on one box out of, let's say, 1,000 that you have in your environment, that should also be kind of a, won't say a red flag, but a yellow flag to get you to look at that and say, why is this different? Why is this not the same as everybody else's? While Windows downloads some weird stuff and does some weird things, it's not going to download these additional tools like that or set up these additional services, especially if you run your endpoints off of like a golden image, off of standard image. If you see something that's different, that should be a cause to look into that. And that's a behavioral based methodology for that.
Yeah, we'll get into these more as he goes through the slides, and you get to actually start working in the workshop, and you'll get a feel for what we're talking about here.
Yeah, for sure. All right. Then the next step is the threat hunting process. We've gone over the methodologies and the principles. What is the process to actually do it? So step one, hypothesis. Form your hypothesis. What are you trying to see? What do we think happened, or what are we trying to validate? Oh,
So yeah,
yes,
your
Leon.
threat hunting. Go ahead, sorry.
Sorry, I just saw that the chat popped up and I was answering it mid talk. Yes, we're going to record this and we can send it out to you after the workshop is over.
So with your workshop time, if you click exit and not end, it'll pause the time on how long your entitlement's active. You should be able to come back to it.
So the hypothesis again, what are we trying to see? We need to have a starting point for what we're trying to observe or what we're trying to hunt for. And again, that could come from CTI, behaviors, or entity based. Or it could just be you want to see if you saw something neat on Twitter and you want to see if that procedure exists on your environment. You can go in there and threat hunt. You know, it can come from anywhere, especially for proactive threat hunting. Any idea you have, you can hunt for. Then step two is data collection. So you're going to gather your telemetry from your log sources. Are we investigating endpoint issues? Do we need network data? Do we need proxy logs? If we don't have logs, it's going to be very difficult to prove what happened, right? So we need to make sure that we have that data collection. Ideally, you should be verifying your data collection before you get into the threat hunting process. But either way, that'll be the next step. And then step three, we're going to analyze that data. We're going to look for abnormalities. If anything is found, we're going to throw it into our investigative process, which is up next. And then if not, we're going to refine our understanding of the environment and then move on to our next hypothesis, move on to our next hunt. And then we get into investigate. If an anomaly was found while you were analyzing the data, can you see other behaviors or logs that are associated with that anomaly? Can you explain what happened? Did that anomaly, like let's say it's evil.exe, did that communicate to any intranet or internet connections? Did it spawn additional processes? Is it a child process of something weird? Like, was it spawned from Adobe perhaps, and someone clicked on a PDF that then launched this macro, which then launched your evil.exe? Kind of starting at one point and branching out to see what else is happening around that anomaly. And you notice I say anomaly a lot because you have to prove malicious behavior. Almost everything will look anomalous if you're trying to find something off, right? So I'm going to call them anomalies until we're kind of more certain, a little more comfortable that this is malicious activity and not just an end user downloading something or anything. So in the investigative process is where we're going to start to piece together kind of the full picture of what's happening, right? Like I said, parent processes, times, files created, registry modifications, network connections, things like that. We're going to kind of determine all that in our investigation or investigative process. And then step 5, refine. So we're going to document our findings, report any of the incidents that we found, educate our teams on any potential gaps that we might have that we found during our investigative process or during our any of these other steps, and then how we're going to shore that up for future use so we have visibility over those logs or over those procedures later on. So all in all, the threat hunting process is pretty simple. When you think of it, you're going to identify what's happening, collect the logs, look for anomalies, investigate those behaviors, create your deliverables like your reports and things like that, and then make sure that those reports are received and understood by who you're sending them to, right?
And this is something you guys will recognize that's a kind of a reoccurring theme in anything cybersecurity nowadays, especially when you start thinking about purple teaming and detection engineering and things like that, is it's always iterative. Just because you did the hunt once and you found nothing doesn't mean you're done. These are things like it's a continuous process. You're constantly checking on things, seeing if some new change might have affected your environment. Maybe there's a new vulnerability that was released that might have given someone the capability or potential to gain access. So now you're wanting to revalidate, recheck, constantly learning about your organization, the environment, and the tools and capabilities you've got running.
Yeah, and with that too, just because you didn't find something, like let's say you're looking for lateral movement via RDP or something like that, just because you didn't see it the first time that you're hunting for it, that doesn't mean that you're like boxes checked, you're good forever, right? That just means that at that point in time, there is no evidence saying that that exists. That doesn't mean that in the future you can't redo the same hunt. Maybe you have them on a scheduled thing for what you think is most likely to happen to your environment or what the most dangerous thing that could happen to your environment is. Like maybe RDP connections from the internet to your domain controller or something like that, so you can run the same hunts, or you can have, dashboards or alerts or things like that set up to hit on these things that you think are important. Just because you didn't see them at this point in time doesn't mean that they won't be there in the future.
Yeah, and a good comparison, this process for threat hunting is a lot like penetration testing. We're just looking at it two different sides of the coin. It's a snapshot in time. Whatever the results are, that's how it was right then and there. It doesn't mean it's going to be that way a week from now, or 6 months from now, or a year from now. Stuff changes way too fast in this field for it to be stagnant like that.
For sure. All right, and then kind of some of those pre-built detections, those Kickstarters we were talking about a few minutes ago. Um, So how do you kickstart your threat hunt other than just kind of aimlessly looking through your logs for anomalous or malicious activity, right? The two main ones that I like, there's a bunch more out there, but these are the ones that I really kind of focus on are Sigma and Splunk's security content. Sigma is an open source structured format for writing detections written in YAML. Sigma HQ houses thousands of detections for us to utilize. You can also contribute your detections in their GitHub repo. It allows defenders to take a Sigma rule, convert it to whatever query language you have, and deploy it in your SIEM to run that detection. And then the Splunk security content is a repo of analytic stores that provide background on TTPs that are mapped to the MITRE framework, the Lockheed Martin kill chain, and the CIS controls. They include Splunk searches, machine learning algorithms, SOAR playbooks if they're available, and it's designed to work together to detect, investigate, and respond to threats. So with that, we were going to put some screenshots on here, but it's there's a lot there, so we're just going to take a second, hop out of this slideshow for a minute. So it's research.splunk github.com. They have an app as well, so you can download the app, and it will continually update with these detections and playbooks. It'll put the macros in there. It'll have the input lookup tables, dashboards, things like that. But if you don't want to install the app, or maybe you're not using Splunk, that's okay. You go over to detections or analytic stories or playbooks, whichever one. We're just going to get into detections right now. See the name. You can filter by technique. Um, got some analytic stories, the date, things like that. I'll just click on one. Windows enable PowerShell web access. That seems bad. You don't want that to happen. So it goes in, it gives you a description of what it is. It gives you the search query right here. Tell by these backticks there that this is a macro, PowerShell macro. It's looking for 4104 and then some script block logs, things like that. It has some other macros in there. Gives you the data source, which is this event code right here. If you want some more information in that, got the macros that are used. Like I said, this backtick on either side of this word, either side of PowerShell, means that it's a macro. So if you don't have the app installed, you can put this macro in there yourself, or you can expand it to just have instead of it having the macro, you could just put this in there. It works the same. Um, and then it goes into some of the APTs that might have used it, what the tactic and technique is, some of the other default configurations, implementations, false positive, risk scores, how to test it, things like that. It's very verbose, gives you a lot of information, a lot of it, excuse me, a lot of information about it. And then if you're familiar with the Splunk attack range, if you want to have this data just pump straight into your SIEM without actually performing these actions on the endpoint, you can utilize the Splunk attack range, and essentially it will put things in there that will hit on this detection. So you can kind of see what it would look like if it happened in your environment. Then the next one is Sigma, like we talked about. Again, we're just going to do a quick little demo of it. So if you just go to github.com/sigmahq/sigma, or just Google Sigma GitHub, it's probably easier. It will take you to this page. Go into rules. It has them broken down by different categories here, like operating systems, web, application, things like that. Most of them are in Windows because that's what most of the world runs off of. Then it goes even more into some categories like process creation, PowerShell, images loaded, things like that. I find you get the most bang for your buck inside of process creation. So you can go in. We'll just look at one real quick. Do Windows at interactive execution. So in here, it has titles, the status of it, a quick description, the references if you want to go back and look at where they pulled this information from. It's got the attack codes and techniques in there. It's got what logs it should exist in. So process creation Windows is going to be probably either your security log or sysmon logs. And then it gets into the detections itself. So this one, the condition for this detection to hit is selection. So it has to have the image end with at, which is the old way to do scheduled tasks, and it has to contain the command line of interactive in there. It also has the fidelity and false positives underneath it. So the higher the fidelity, the better the alert, right? So Sigma, we're going to get more into it. We're going to convert a rule a little bit later on, but that's typically where I like to go, or we will create our own Sigma rules if one doesn't exist. It's very, very useful to kind of kickstart your threat hunt once you get an idea of what you're looking for. They also have a page called detection.fyi. This is just a more user-friendly way to look at it. So all of these rules are related back to the Sigma GitHub. You can search for them over here, like 7-zip will give you some rules. Click on that one. So you see it's the same. It's just a little more user-friendly if you don't like the feel of like the alt text of GitHub. And you could also just click that. It will take you back to that rule inside of GitHub, things like that. So those are kind of the three main Kickstarters that we like to point people in to go ahead. If you're not really sure where to start or how to detect something, either the Splunk security content or Sigma rules is probably a safe bet to go ahead and get started on. All right. And with that, I've been talking for a little while, so we're going to take a break. Go ahead and stretch your legs. We're going to give it about 10 minutes. For this, we're just going to go inside of Sigma and the Splunk security content. Just look around a little bit. Think of how you could utilize it in your environment, how you could utilize it to kickstart some of your threat hunts. grab some water, things like that. We'll see you guys in about 10 minutes or so.
And again, if anyone hasn't received their lab link yet or hasn't been able to access it, please let me know so I can get you a new link. And here, I'll chat with you guys for a minute too while Tyler's taking a break. I know this is kind of a fire hose of information that's coming at you guys. We've got a few hours to teach a bunch of very big concepts. So we don't expect you to be experts and master it all at this one point in time. A lot of this is tidbits and things to help you think about this process, how you could implement it, and kind of get you excited about moving forward with it. Threat hunting is one of those things where there's no easy answer or no one right way to do it. Everyone has their own way. Tyler and I kind of put this together based off of our own prior experience, some of the previous doctrine and ways that we've been taught to do it, the ways we think seen things work, stuff we've seen go terribly, and kind of condensed all of that down into this course for you guys. If you enjoy this at the end, please let us know, and we can make a more advanced workshop of this one, maybe a part two, and move it forward. Let's see. For the question, we have Elastic on the Unicorn Labs host. Right now, it is used for nothing. We initially, version one of this course was running off of Elastic. As we've been updating it, Tyler and I moved to Splunk. So all of the logs are being ingested and sent into the Splunk instance now. Hamaz, are we allowed to network? Sure, feel free to share your LinkedIn profile away or network to the people in the course. This is an opportunity for you guys. We're here just to pass some knowledge along, give you guys a chance to play with some pretty cool tools and get to know us a little better. So if you guys make connections through this, that's still awesome to see, right? How do you log into the Windows VM? You should not need, or sorry, the Windows VM. So that is going to be Unicorn. When you click on it, the username should be unicorn. The password should be unicorn11, or it should be unicorn, sorry. Let me go to consoles. I'll pull mine up and then I'll just share screen if that's easier. And let's see, is there a LinkedIn post for this that I can share? Martin, yes, there is very much a LinkedIn post for this workshops. Once we get back into the slides, I'll go and grab a link to it and throw it in here. Or if we've got any of our hidden Scythe agents floating around in the chat right now, if you guys could share the link to it, that would be awesome. Thanks for the kind praise there, Courtney. Yeah, this was a really cool one to put together, and we feel like everyone could use some exposure to this. It's not a singular role or responsibility, so we wanted to make sure it was put out there. All right, here we go. My lab loaded. So I will share this screen now, just to give you guys a little bit of familiarization. Share. Place the current share. You guys see my screen fine? Cool. Okay.
Yes.
So as you go to the Unicorn lab host, I'll go ahead and do this just so you can see it. This panel over here, if you click on the arrows, you can expand and collapse it. That's going to have your access for the lab manual. Any credentials you'll need are here on page one. To access the consoles, they're here. For the primary Windows host you'll utilize throughout this lab, it's going to be Unicorn 2. As you click on that console, it's going to take you to this screen here like you see on mine. A few little tricks with working with VLP. It gets kind of finicky. So to pass it, Control Alt Delete, come up here to this keyboard where the shortcut is, hit it, select Control Alt Delete. The username is unicorn and the password is unicorn. So, and that should let you in on the onto the desktop. Martin, sorry about. I will send you your link right now. I must have missed you in the chat a second ago. Yep. So once you do that, it'll put you onto the host. Any of the other weird pop-ups or anything like that, you can just ignore them. Everything you need from this point on is accessible from here. Let me. So yeah, I guess real quick, a couple other easy things to look at here in VLP. If you need to key and paste, sometimes the direct like hypervisor copy through the browser gets weird. You can use this button up here. It looks like a clipboard. You can put your text in here and hit send, and wherever you have your cursor clicked, like for example, I'll open Chrome. So I'll put this here. I'll go keyboard. Let's say fc.com. When I hit send, it'll throw it there. See that? And then you can search. Again, the keyboard shortcuts will be super helpful. If you want to, or like you're having issues, you can use this console actions button to like refresh or reset the VM. You shouldn't have to, but those are there just in case. And you can also use this button to full screen the console. The other thing to be aware of here, this big blue button that says Finish Lab, when you select this, you have two options, exit or end. If you click exit, you'll be able to reuse your lab link and come back in here and continue working on the lab. If you click end, it is going to tear your instance down and delete it, and your link will be dead. Let's see, Daniel. All right, I'll get you a link too. So Martin and Daniel. Yeah, there you go. That was just a real quick how you get into this and what you see. Most of everything else you're going to do is going to be from here on this Unicorn host. So in the Chrome tab browser, there's links, all the tools and everything we're going to talk about or utilize today. There you go. I was just giving him a quick walkthrough while you were taking a break there, Tyler.
Yeah, awesome.
Let me go and pass out some lab links.
All right. That should be enough time, I think. Let me reshare my screen. Did anybody find anything useful or interesting in either the Sigma or the Splunk security content? It's really neat. It's we had used the app on my old team. It's great how it'll put all the it kind of just like gives you a little cheat code to it puts all the macros in there. It's not quite just like a click and go. There's always some kind of, there's always some you have to make, or maybe your source types are a little different, or like some minor adjustments. But it's a great starting point just to kind of see, um, a great starting point to just kickstart kind of what you're looking for. And I love all the context that it provides around it. I think that's something that we miss out on a lot. It's and I'll talk to it later as well. Like without having context of what's happening, it can be difficult to see what the importance is of it, or like why do you care about it. See, I like that they include that in the in security content. I believe that Elastic Labs also has one, but I'm not as familiar with that, and I don't want to put anything there that I don't really know anything about. So, if anybody has any other detection Kickstarters or things like that, please throw them in the chat so we could all kind of get a little better, and we can all improve, and kind of we're all in this together, right? We all want the same thing. Find the bad guy. So if anybody else has any other links, please throw them in the chat so we can all use them. But with that, we will continue on. So we'd gone over kind of the what and how of threat hunting. Or no, we've gone over the what it is. So now let's get into the how we're going to do it. So in this section, we'll go over SIEMs, and by SIEMs I mean Splunk, the benefits, and then some search tips. I don't really get into how to make searches or how to create queries in and of themselves. We do that in the lab. So if you need any help with that, once we get into the lab, please let me know and I can kind of break that down a little bit more. But with all that, let's get into this very, very busy slide about Splunk, about our SIEM. So we strongly recommend that defenders have all their pertinent logs forwarded and ingested by a SIEM. If it's not Splunk, that's okay. Ingest your logs into a SIEM. The SIEM will provide you with a centralized location to hunt across your entire environment. Right? You can configure it to provide automated alerts or perform actions based off of the alerts. Even outside of the cyber realm, if you set up an alert that monitors for your milk level in fridge.log, you can have your SIEM configured to send you an email of its status or integrate that query into a food delivery service like DoorDash and have them deliver you milk without even you interacting with it. And that way, you never run out of milk. You never forget to buy milk. In the more security sense of it, you can utilize your SIEM to have a centralized view, real-time monitoring, helps with threat detection, instant response, historical analysis, operational efficiency, data enrichment. It's scalable. It allows you to correlate events, like I said, across your environment in real time. You can set up alerting. It just gives you a much better. It can give you a 1,000-foot view or a 10-inch view in your environment, in your logs, and it makes it a lot easier to perform threat hunting across multiple machines because it's all in one spot, right? If you are not ingesting your logs, you might have to go to your EDR website or your EDR dashboard. You might have to RDP or run some kind of PowerShell of remoting to pull event logs off multiple machines, or you might have to open up 10 different windows of your different security tool to kind of piece together what's happening. With the SIEM, you can forward all of your event logs from your host to it, your sysmon operational logs, if you're running that, your EDR logs, firewall, Zeek logs, formerly Bro, your network security monitoring logs, your milk logs, your fridge logs. You can forward everything into one spot, and it's just so much easier. Yeah, without having a central point to look for things, it is very easy to miss what is happening because there is so much data and so much information. You need to have it in one spot, or
Well,
as much as you can in one spot.
the other scary thing here, Tyler, is we mentioned it again earlier, and it's one of those things where logs are it didn't happen, right? If you're not
Mhm.
collecting logs, how do you go back and find the bad during an incident or prove that something happened or didn't happen?
Yep.
And we've seen it more and more, and it's really scary how reliant people are getting on these so-called magic buttons or
Yep.
their EDRs or other like star R's tools, whatever it
Yep.
happens to be called this week, because they're expecting the tool to just tell them about everything bad. And we've known from experience, it's been proven time and time again that they are good. Don't get me wrong. Today's day and age, it's mind blowing how well some of these tools work, but they're not infallible. They don't collect everything. And then from a hunting and an incident response perspective, for you as the defender and the user, a lot of the times information is hidden or it's put under these fancy tags called heuristics or some
Yep.
weird magic formula that the company uses to determine good from bad. So you don't actually know what happened or you can't see why there was an alert or what was going on. You just know there was one and something bad happened. So relying purely on one singular tool to just tell you when something is going on is kind of an epidemic, I would say, in cyber these days, and very scary. We need to make sure that I look at it back from like the time we're in the military, like the two is one rule, right? If you've only got one of a thing, well, really, you've got nothing because you're ineffective once it breaks. If you've
Mhm.
got a backup or you've got multiple sources or multiple ways of doing a thing, determining a thing, you're covered. In the event that something does go wrong, you've got multiple avenues of approach to try and validate and check.
Yeah, for sure. But say that was a thing that really kind of blew my mind when we left the team. And now we do all these purple team engagements with different clients and customers and all kinds of verticals. And I'll ask them, like, what is your threat hunting policy? Like, what is your SOP to perform threat hunting? They're like, oh, we just wait for an alert, and then we just kind of, thumbs up, thumbs down on that alert. If the EDR took care of it, then that's the end of it. And that is just like crazy to me that people aren't proactively looking for the bad guy. Yeah, it's just crazy to me. Yeah, make sure you have everything in one spot as much as possible. Yeah, I cannot overstate how valuable it is. But enough of
So
that. Oh, good.
I know you're good. I just wanted to touch on Carson's question real fast.
Oh,
Thanks
yeah,
for
go ahead.
interacting, guys. This makes it so much more fun for us because we're just kind of talking into the void that is our webcam. So your questions and comments and interaction is super helpful. We appreciate it. To answer that question, like, do we have a recommendation for a SIEM that is more fit towards small, medium-sized businesses? Yeah, demoing something like Splunk, it works well for a reason. Like you're going to pay for the service. And ideally, that the next step for free or freemium, small, medium size, you can't go wrong with Elastic. For what it does, it functions really well. It has a lot of good integrations and tie-ins with other tooling. And it's kind of the standard there, right? Most people we see, if they're not on Splunk, they're using Elastic.
Hmm.
So it's a great place to start for a SIEM. And yeah, there is another comment down here that says Security Onion's good and open source too. That's a great point. Security Onion as a platform has a lot of this security tooling built in place, and it's free and open source. It has Elastic or Kibana built in as the SIEM of choice, and Security Onion along with all the other tooling. So there's a good one. We've seen some people using Waza. We've seen some other of the obscure or other brands. A SIEM is a SIEM is a SIEM. Some are going to be more easier to work with. Some are going to be harder. It's it's that typical issue you kind of have when you think about open source tooling or paying for tooling. You can go with free, it might work, it might be great, but it's going to require significantly more time spent maintaining and working with it as opposed to paying for a product and a service. You're going to get everything you need in a nice fancy box and bow, but it's going to cost you, right? So you kind of have to balance that line of what's best for you and your organization.
Yeah, for sure. By saying I see a bunch of Security Onion stuff in the chat as well. Security Onion is a great um, platform. I'll call it a platform. We ran it on the team for our network security monitoring, so running Zeek and Snort, Suricata, things like that through it. We didn't use the Elastic part of it, but it comes already installed. It has the Hive, so you can put your test cases in there for like tracking and things like that. We utilize Security Onion and would just turn off Elastic and stand up Splunk and point the logs to Splunk that way. So you can even use it interchangeably. You can go into the config and disable whatever it is that you don't want to run. You can pin CPUs to it. It is a great open source product. Yeah, could not recommend it more. It's awesome. It's very easy to install. It's very easy to learn. Yeah, if you're looking for a way to get started or even have one in your home lab or in your house, Security Onion is probably the way to go. But with that, we will get into what sources do we have. So it is imperative that you know what logs and log sources you have ingesting into your SIEM and from what hosts, right? That way you know what you should be able to hunt on and pivot off of. So you don't want to make assumptions when it comes to your log ingestion. You want to verify what sources you have before you wind up in an incident and you're faced with that harsh reality that your logs are not what you thought they were. You want to make sure that you're ingesting them, the machines that you think you're supposed to the machines that you want to have logs from, you are getting logs from. You want to make sure that they're being parsed correctly, that you can search on them. You want to make sure that you do this proactively ahead of time. You don't want to be in an incident and that's the first time you get in and you realize, oh, we're not ingesting, our EDR logs, or oh, we're not ingesting our security logs, or our domain controller isn't pushing our logs to our SIEM like we thought it was. You want to verify this. Um, so here I have listed just some metadata queries that will help you to identify what sources, source types, and host you have logs for. I would recommend that you ingest at a minimum your endpoint security logs, EDR or sysmon logs, which is what we have in our lab, as well as any NSM, so those network security monitoring tools like Zeek or your IPS or IDS intrusion prevention or detection systems. You want to get all those logs forwarded in one spot. That is a great place to go. And then from there, because it costs money to store these logs, right? It's not free. Storage is not free. So you want to make sure that at a minimum you have those in there. And then if you have to pivot into other tools independently because of just like the storage size or things like that, that's okay. But that's going to be kind of up to you and your risk appetite and your budgetary concerns and things like that. But at a minimum, you want to have probably what you see here ingested into your environment. And then in our lab environment, we are ingesting sysmon logs, endpoint security logs, application logs. We don't have any network logs being sent to our SIEM. It's all going to be host based, but you can still see network connections in the host logs, and we'll show that once we get to it. Oh, and I like the metadata commands for this. So specifically, if you're in Splunk, the metadata commands are much faster. Like they only take. I wonder if it has the time on there. Oh, and some of the you can see how long it took to run the query inside of Splunk, but it only takes a few seconds compared to if you're trying to run this like all time, it could crash your system depending on how many logs you have. So running these huge searches like this, I would recommend using the metadata commands is much faster. All right. So like I said, we're not going to really get into how to structure a query. That's going to be we have some examples of that in the labs, but we are going to get into how to organize your data. So if you just do a query and you don't have it tabled or some other ways we're going to show here in a second, it's just a lot. It's a big chunks of data that's hard to parse through. It's hard to make heads or tails of what's happening. So to organize it, the first way that I like to do that is to table. So seams work by searching for specific values inside of fields. In this example we have on the right, we're searching for event code 1, which is process creation in Sysmon, and the parent image or the parent process of either PowerShell or command prompt. So searching just on these values without organizing them will probably be pretty cumbersome, and you'll be pretty inundated with all of that data, and it's going to be very hard to find the information that you're looking for. So to alleviate that, kind of the first part we're going to talk about is using the pipe table command, which will only show what fields you want to see. So for process creation, I would recommend displaying time, parent image, parent command line, and command line values. This will give you a great overview of information that's really important and should have some things stick out as you look at it, but it's excuse me. So it'll give you that great overview, but it could still be pretty cumbersome if your time window is too large or you have too many values returned. So this command just looking for the parent image of PowerShell or command prompt. If you looked over like 24 hours on a thousand machines or so, you're going to get a ton of data, too much data. You're not going to be able to even look through it. So with the table, I like to do that with a smaller time window. You see in our query here, I have it specified just to one host, and I specify what source type and index I wanted to look into. So you want to be as specific as possible, but if you're looking over, like I said, anything over 4 hours, the table command could quickly kind of get away from you. So for that, to remove some of that excess information, we can utilize something like the pipe stats command. So the most common pipe stats command I use is values, which I have in the search bar there. Excuse me. So the stats values will display just the values of a specific field in reference to another value or another field. So in this example, we want to see all the command line values that exist for each image. And those images are PowerShell or command prompt that we have in there. That way we're able to more efficiently and effectively kind of group together the information we want to see without being so inundated with all of that extra information that things get lost, right? But how table gives you a lot of information, stats can give you not as much information sometimes. So definitely a con to using the stats is you might miss out on some other pertinent information that you want. So I would you want to start your queries with a wide net that captures more than you think you need, and then you kind of focus in and scope down as you find more pertinent information, right? So it's like when you go fishing, do you want to fish? You're going to go out, you're going to throw your casting net, you're going to get some bait, going to look at a couple different areas, see where the fish are at, see what pops up. Then you're going to put that bait on that hook and then kind of focus in on closer and closer areas like that. You want to kind of start wide and then focus in as you go. If you start too narrow too soon and then you see something that you think is anomalous, you're going to just get focused in on that, and you're probably not going to step back and kind of look at the whole picture. So again, start wide, kind of go in. And then stats has more than just the values command. That's the most common one that I use. Some other really common ones are stats count, which will provide you with a number of how many times that field's values appears. So if you wanted to see like how many you want to count of how many times the parent image of PowerShell was ran on multiple machines. You could do like stats count by image, and that'll give you PowerShell was ran 5 times or 10 times or whatever, just to give you that numerical count. That's good for finding things that are either launched too many times or too few times. So if you want, if you see evil dot, or you're looking for services that are uncommon, or even like domains that are uncommon, you could do a stats count on that and see which ones are like 1 or 2, and maybe you want to investigate those because it's not common in your environment. Another stats command that's utilized a lot is sum, S-U-M. So just like Excel, it'll add up those fields values. Though that is really useful for when you're hunting for like data exfiltration or things like that, because you can add together all of the bytes that are leaving from each individual machine to maybe a domain or IP address. So if you see a lot of bytes, a lot of megabytes or gigs or whatever going to a specific website, that is unusual, that you don't see very often, that could be cause for a threat hunt or something like that. All right, so that one is quick. I just wanted just a brief overview of Splunk and kind of how to group the data together. So now we'll take another break for our labs. Trey already went over the familiarize yourself with VLP in the last one, so we have a slide on that if you want to read over it. It's this the same stuff he was talking about. Then we're going to deploy some threats via Scythe. We need to deploy these threats so that way we're able to populate our SIEM with these logs, and then we're going to do our first hunt inside of Splunk. This is a very simple one that we're going to do just to kind of get you familiar with Splunk, using the table command, using the stats command, things like that. So we'll give about 20 or 30 minutes for this. We'll probably do a check-in in about 10 minutes and see where everyone is at. And then we'll do kind of a quick walkthrough of this as well. So with that, let's get started on the lab. This will take you to page 17 in the manual. So that everybody can hop in and let us know if you have any questions, and we'll see you in about 10 minutes or so.
Andrew, the manual is in VLP itself. So here, let me pull my screen back up and share it. Should be this one. Screen. All right, here we go. So Andrew, as you are looking in the VLP lab itself, over here on the right, you'll have some collapsing arrows with a piece of paper. If you expand that, the manual tab has everything that we're doing within the lab itself. You can click these arrows here on the left and right to navigate through it, or you can click on the hamburger, and it'll give you a drop down to get through it all. So, Edward, as you're creating your campaign, it's going to say pending until it's active. If you go over to the right of it in Scythe, you should see, here, I can just do it real quick. Why not? Let me open that back up. Here we go. We'll close this down. Control delete. So, events, proceed, expand. Yeah, I typed the password correct, huh? One. It is 3 bangs, not 2.
Yeah, I had to have at least both characters. That's why it's different than the Splunk one.
Okay. So for those of you having issues with the pending side campaign, here's how we go about it. I'm going to hop in here real quick. I'll create our first campaign. We can see what's active or not from this campaigns tab, and we can start a new one by using this fancy blue button up here. I'll click that. We'll call this Super Cool Test. Stuff and things. You can pick your target operating system. For Scythe, we can build implants in Windows, Mac OS, or Linux. Just pick your flavor. And then below that, you can see the communications modules we're utilizing. We'll use HTTPS for this lab. Most of the rest of the stuff you don't need to mess with, but just if you were curious and wanted to step through it, you have a lot more granular control over the campaign and the implants themselves. You can choose to auto send your campaign results to the assessments tooling. You can have auto pause turned on. This will allow you to stop and start the campaign between behaviors and control its movement. Or you can put some guardrails in place by restricting the campaign to a specific date range, a specific device, or fully qualified domain name. So to make sure your payloads and implants don't get executed any time or any place they're not supposed to be. You can control some of these other features. You guys don't have to do any of this though. Things like how the headers look, the heartbeat and jitter, all the typical things you'd expect from a C2. We'll hit next. I'm going to just add a couple steps to this campaign to make it work. Let's go with, we'll do run. Come down here, execute, create a custom action. I'm gonna say run. Let's do the who am I command. Everybody's still super concerned with that, right? And then I'll hit create campaign. Once you do that, this should take you to the screen like you see right now that I have. And I think this is where some of you guys are stuck, where this says pending, correct? So from here, you've got two options. The first one is you can click here and download the payload in whatever format you want, or you can come over here to the right of that pending where the three dots are, select this, hit direct download links, and choose the payload type you want. So we'll just say, let's go with 64-bit executable. Done. I'll come over here, right click, paste and go. Advanced, proceed, service login. So now that you've got that file, what you'll want to do next, let's go downloads, is rename this. So rename none. By doing that, now I've got my payload. I'm going to run this real fast. Once you run the payload, you should see the state of your campaign change from pending to active, like mine just did. And now it's going to step through and execute whatever behaviors you had put in place. So Andrew, to answer your question, we have not provided it out yet. We'll make slides and stuff like that available after the fact. So now we can see the campaign ran through, it issued the command I asked it to provide, and now it's waiting for further instructions. Did that make sense to everybody? Cool. Awesome. So you guys should be able to continue on then through the lab from there. Question there. What are the differences of threat hunting in the OT environment compared to IT, if any? There's some, but the difference is realistically they're not a lot. You're working with different kind of security models, so the way your data and your hosts and things like that might be structured is a little different. And you're potentially working with some more bespoke or uncommon protocols that traditional IT won't see. So you'll have to have a greater understanding of the organization, the environment, and what those processes and things are doing within the OT space. So like the stuff you'll see, the data being logged and activities happening in a manufacturing plant might be different from someone that does power transportation and generation, and the tools and equipment are different. So your log sources may be different. That's really kind of where the variance is. In the overall concept, the mindset is still the same. You're trying to find bad within your domain, within your good. Let's see. Start saying I'm stuck. Where are you stuck? Okay, Andrew, you should have received an email from, actually, no, I'll just send it to you. It'll be faster. I'll give you your link and a message here in 1 second. Okay, you were a late edition, I'm guessing. Is going to be
Yeah, so the run module under modules should just be under load a module, and you can scroll until you see run. I already let me unload, delete that. Should show up right here with the VLP screens. It like kind of smushes in the first page. So it might be easier if you do just like a zoom out to be able to see more of them. Um, and then if you don't want to search for it, you could just in this search actions type run, and then it'll pop up right there. You just click it and it'll add it over here. And then you can get rid of that and go into custom actions. And then that's where you're going to put the run commands in there.
uh, Carson, yeah, for the sake of the lab, we're just going to keep it easy. You can run the campaign directly on the same host that you're operating from.
Yeah. If you want to get real crazy, you could send it to your production machine and deploy it there. I'm just kidding. Don't do that. Some we'll say it. A lot of our customers do deploy these threats in their production environment, so they are safe to run in your production environments. Some are a little more disruptive than others, but a lot of our customers do run them in their production environments. I ran one the other day in our test lab that I forgot disabled RDP, and so after I ran it, it kicked me out, and I was like, well, I don't know how to get back into this thing. So I had to do a little bit of a workaround to get into that. But for the most part, they're safe to be deployed in your environment. It's not going to break anything. Um, yeah, no, it's not going to lock up the threat. When we get into the lockbit part, we'll talk about kind of how we emulate ransomware, but it's not going to encrypt any of the actual important files. And then, what do you mean by copy the path of the exe?
I think from where you're trying to get the direct download link is what he's trying to see.
Oh, okay. Well, let me go ahead and just finish making this threat, and then I will show you. So we do print screen, ARP, gonna run who am I, and then has us do a custom action of run, type system info, add action. Then we're gonna go up to, excuse me, sorry, everybody. Up to sequence templates. So up here at the top under available actions, sequence templates, going to click on add attack techniques. So this is, we have between us and the Atomic Red Team tests, we have loaded in here a bunch of different kind of just like one-click emulations that you can perform that are all tied to the MITRE ATT&CK framework. So for this, we could look under discovery. I don't really like to look. I like to just search like that. So you can type in the T code in the top, which is 1124, like system time discovery. And we are going to do system time discovery right there at the top. Click configure and add steps. And what that's going to do is add in these two commands and tag them into our campaign. So it's easy to go in here, and if you want to emulate lateral movement RDP, you can click on that and add it to it. If it has any prereqs or inputs it needs you to fill out or anything like that, they'll be placed here. And once you add it, it'll add those steps to your attack. But I don't want to do that, so I will delete these ones. Ooh. All right, so then that's it for that. We're going to create this campaign. It's created, and then how does it have us download this one? So we're gonna check this box, click all the way on the left to this download selected campaigns. This one's going to be a DLL. We're gonna change the entry point to DLL register server, and then click download client. We're going to allow this, download unverified file. Then go to where it is downloaded, which should be in your download directory. And we are going to change the name of this to dar.dll. And then from there, going to open a PowerShell admin. Actually, we don't need PowerShell. We'll just open command prompt straight from there. This is a neat trick that I just learned a couple days ago. If you go in the URL bar and just type CMD, it will launch a command prompt from where you're at, which I think is really neat. Or if you do shift right click inside the folder, you can open PowerShell window straight from that folder. But for this, we just need command prompt, and you can either copy and paste it over. I'm just going to type it out. So we'll do run dll32.exe, and then we're going to run dar.dll, and then we're going to give it the what's it called, the entry point. So from inside of that, that's all that we need to run it. Hit enter, and it should change from pending to active here in a second. As long as I typed everything in right. Slash press enter. I guess I didn't press enter the first time. So now we have it is checked in, so we get active. You can click the drop down there for each. So if you deploy this campaign multiple times, you'll get a new box with the new PID under each of these. Or if you deploy these to multiple different machines, the host name will be reflected there. So once it's running, we can click on the device unicorn, and we can see its actions going through it. So it loaded the modules in. It goes from bottom to top, so latest to earliest. So the latest to earliest over there. And if you click on the arrow on the left, you can see the request. So in this, we did ARP. Oh, it's because I ran it as the module. That's why there's no request. But then you can see the response down here. And then the same for these, like this run command, system info, and then you can see the output there. And then once it is done running, the last thing we have should be system time. Yep. You can also open a shell. So you can use this if there's extra commands you want to run inside of it. Like I could do run IP config. And it takes a second for it to poll. So we set the jitter time. I think by default, it's 5 or 10 seconds for each check-in. So after a few seconds, you should get a response back. And then when you're done with this campaign, you can do controller tac shutdown and press enter. And then after a few seconds, it will shut down that implant. It'll kill the process, and this campaign will be dead here in a few seconds. And then we're also going to deploy an existing threat. So we'll go into create campaign. The campaign names don't really matter. It's always going to download as that service login. So the campaign names are really just for you, but I'll call it Lockbit v3. Doesn't need a description. You can leave all of the default set. Going to add existing threats. Look at here. So this is our catalog of all the threats that we currently have. Scroll down, Lockbit v3. So we have 2 of them in here. It shouldn't matter which one you click on. I think I made a minor change to one of them, and that's why that there's 2 of them in there. So I will just do the normally named one. Should have everything, and then you can see over here on the right. Try not to look at all the steps it's going to run, because this is the one we're going to hunt through. But it's okay either way. You know, this is just a training environment. So here you can see all the steps that are run, and we can go in. I'm gonna delete the mutex because I don't care about that. Create the campaign, and then from here we're gonna download it the same way. Click download 64-bit. This is going to be an exe. We're going to download it. Download unverified file. Once that is downloaded all the way, you can just right click and run as admin. Oh, I did not rename it. That's what I get for not paying attention, right? So what I will do is once it checks in, I will go in and kill it. You can also just run the campaign again and change the name of it, but I'm going to do it this way. So once it is, let that shut down, change this to h1.exe, and then we will run as admin and launch that one. You can also, how Trey and I will most commonly use this in our purple team engagements or to our lab or anything like that. You can also do a direct download link. So these are links that will download the campaign either as a DLL, exe, shellcode, and DLL, things like that. So you can copy the URL and go into PowerShell, is how we like to do it, and do a wget URI. You give it that direct download link, out file, and I want this to download, call it h1.exe, and then there it is right there. And then you can launch it from there. So that's really useful if you're doing like a spear phishing campaign or embedded macro, or it's just a really easy way to kind of move it around without actually sending malware all the way across. You can just download it directly from there with the download cradle. And then with that, I'll just continue walking through the rest of this part. Was everybody able to execute the campaigns? I have one failure on here. I wonder what that is. Oh, it's good. Yeah. So some of them, so you can see that we have some successes or succeeded and some failed. Some of them are, I don't want to say designed to fail, but okay to fail. So there's some threats we have that will try to query like a domain controller or do some other things like that that might not exist on every system, or it could be blocked like in actual engagements. It could be blocked by a EDR or by your by any kind of policies you have or GPOs or things like that. So if you see failed, it ran the command. It's just it gets that off of the response code, but we'll still see that command being run in Splunk even if it was not able to execute on the system because it was blocked for whatever reason. So we'll let these go through. We'll switch over to Splunk. Should just be clicking on the bookmark there. The username and password are saved, but it's unicorn for the username and then unicorn exclamation point, no, 1 exclamation point exclamation point for the password. It should be up there at the top of page 10. So we'll go to search and reporting. Please make sure you set your time to all time. It's not a good practice in real life, but for our lab, there's some time skew because the lab isn't always on and it's linked to the domain controller. So sometimes there's the time is not accurate, so it thinks events happen in the future. If you've used Splunk in a lab or if you use Splunk around like multiple different points around the planet, the time is all different. So you might have run into this before, but just set it to all time, and then we'll go in, we'll do search index equals main, source equals win event log, sysmon operational, image equals system info, and parent, oh, we gotta capitalize the I for image, and then parent image equals run DLL 32. And we can see that we get a result back. This is what I was talking about before, where it can be like this doesn't really tell you much, right? It doesn't show you all the lines, it doesn't show you all the fields or all the values. You do have some interesting fields over here. You can click on and see, like it was ran from the downloads directory. That's probably not good. Hashes, if they're applicable, things like that. This is a great time to use the pipe command, which you can then go in and give it underscore time, parent image, parent command line, command line. Oh, I forgot to write table, sorry. And then it'll show it in, I think, a much cleaner way. That's a lot easier to kind of ascertain what happened, right? Then we have some questions in there at the bottom. We have in this section with open Splunk executed a query. What index did the results come from in the search? So I'll just go over the search. So we're looking at index equals main. Index is where you can think of it like a bucket almost, right? Or like a door in your room. All of your sources and source types, you can set it to what index you want it to go in. Main is the default. You could have it broken down into index is proxy logs, index is host logs, index is system information, anything that you want to have it set to. Ours is currently just set to main. Then the source is where those logs are coming from. So the source for this is the sysmon operational logs. And then our image or the process that we're looking for is system info, which we ran in our campaign, which we want to show that system info was run, and then the parent image of run DLL32, because that is the parent process that then spawned system info. And then we want to just table out, which will again just show you the exact fields that you want to see. So it'll table out the time, parent image or the parent process, the image that that parent process spawned, the parent command line, which is what was run to then spawn the command line, which is system info. So basically we see here that run DLL spawned system info.exe. How did it do that? Run DLL ran run DLL dar.dll DLL registrar server, which is what we ran here in the command line. And then that then proceeded to run system info. Then we have a question here, parent image, run DLL. Okay, so the difference in those two are just the asterisks. So the asterisk here is a wildcard. So it means that it doesn't matter what's in front of it or behind it. If it contains the word system info, we want it to trigger. So like if I took system info out of image, or I took the asterisk out of image, we don't have any results. And the reason for that is because in front of system info and behind system info, we have this and the .exe. So if we would have to, you could change that, you could change it to that and get rid of the asterisk on the backside and just have system info.exe. Oh, look, it looks like our lockbit emulation has run all the way through. You could just minimize that. We'll get to that later. So yeah, that is essentially what the query is doing. So we have what index did our results come from in the search? It came from the main index. And then what is the computer name that the log result originated from? We don't have that in this info, but what we can do is we can add host at the end, and host is unicorn. What you could also do is switch this to verbose mode, and you could go over to events, and then you have all of the interesting fields on the left, or you could see everything that happened. You could see that the host is unicorn. So we know it was ran on the unicorn box. So yeah, if you're doing keyword searching, asterisks are normally your best bet. You don't. I think that it's fine to use in this format here, where we have it, where we still give it some context on what we want it to look for. What I would not use it for is like source equals star, right? So that'll look in all of the sources. So it will work with this, but again, depending on your system and your system resources and how many logs you have and hosts you have and sources you have, if you give it that asterisk, it's going to look at all of it. So it's going to use a lot of cycles. It's going to use a lot of memory. It uses a lot of resources to do that. So I would be as specific as possible for you to do it. And then type CMD navigation bar. Yeah, so on that Windows computer on the unicorn box, if you go up here after you've downloaded the campaigns and just type CMD, it'll pop up that command shell, and then you can run it from inside of there. And then we have the same with the who am I? 1 second, let's get reoriented. So in this one, we see that we're just going to search for image equals who am I here. I'm going to leave all the table stuff in there for right now. Who am I? So we can see that who am I was also ran by multiple different parent images, both by h1.exe.exe because I renamed it incorrectly, I guess, but that's okay. As well as run DLL32 and the Scythe client, see that all of those ran who am I in some form or fashion. All right, we'll translate the Sigma rule. Just kind of show how to go in and use it. So this Sigma rule is process creation on Windows system time lookup. So we'll go into Sigma rules, into time lookup. Gonna open this file. I want to update. Gonna copy all this. We're gonna go over to sigconverter.io. Didn't mean to do that over Splunk. That's okay. And then we're just gonna copy and paste that in there, which the copy and paste is weird in this. 1 second. Copy. All right. Yeah, the copy and paste inside of VLP can be a little confusing, which is why we put on the next slide, we put the actual command itself in there. So we'll look at the rule first. What is the rule looking for? Process creation, and we are looking for the condition is selection. So it has to have this /c and time, and we want it to be spawned by cmd.exe. That's what this rule is looking for. When you go ahead and if the copy paste worked, it would look something like this, where you would put all of the you would put the rule in on the left, choose Splunk up here, and the query it would give you on the right hand side. So we would copy out the query on the right and go into Splunk again, search and reporting, and we put the detection in here because, or the query in there, because like I said, sometimes the formatting can be a little wonky. Should be able to just copy and paste this actually. Let's see. There we go. Into that, I'm going to set this again to all time. And then in here, I'm just going to cut right to the table, time, image, command line. And we can see, let's put parent image in there as well, because I like seeing who spawned it. So inside of parent image, we see that run DLL executed command prompt, which then spawned this command line so that they are trying to ascertain or do discovery on the net time you have on the local host. And that'll put us all the way through this lab. Just kind of a quick run through in how to deploy campaigns via Scythe, as well as how to kind of navigate Splunk to find some of these actions that we had executed. Says, looks like the lab is missing VFS shared and the campaign is not working. Is that for the, does it give you that step 5? Okay, I think that's the mutex that's in there. What you can do is go ahead and create campaign, give it, that's the wrong one, add existing threats down to lockbit v3. It must have had some issue when we imported these in there, so I'm sorry about that. So what you can do is recreate that campaign, and on step 5 here, where it has it try to pull down the mutex.ps1, just click these 3 dots and click delete, and it'll get rid of it, and then you can create the campaign and execute it that way. So sorry about that. There must have been some issue when I uploaded the threat that it didn't put that in the virtual file system. So sorry about that. All right. Is everybody able to get through some of these pieces, or at least get the campaigns to execute and do, 1 or 2 of the searches? Okay, fantastic. Trey has kindly reminded me that I am taking too long, so I will try to speed it up. 1 second. Let me stop the share and open this back up. Share, hunting through the seam. Excuse me. All right. So now I'm going to kind of walk you. Sorry about that. Now I'm going to walk you guys through a hunt scenario. This will be, gonna kind of go over it. We're going to do a hunt scenario. After this scenario, we're going to drop back into the lab and you're effectively going to hunt on your own. We'll give it a little bit of time and then we'll step in, kind of go over it, have you guys finish the lab, and go through it. But with that, let's get to what we all want to do, and that's hunt, actually hunting through the scene. Alrighty, so our first hunt scenario is going to be an intel-based hunt. Before we get into it too much, what we're talking about here is not the campaign that we executed on our system. This is not Lockbit V3. This is going to be a Volt Typhoon threat that we're just going to talk through and walk through, just to kind of give an overview of how to do it, and then we'll go into the labs and actually run the commands, run the queries, things like that. All right, so an intelligence-based hunt. So our intelligence cell has a high confidence that Volt Typhoon has targeted our organization, and it has provided us with their observed TTPs. The intel report, or the CTI, the cyber threat intelligence, is going to be the launch pad for our hypothesis and our hunt plan. So form hypothesis based off of the CTI they've provided us, which is this just a snippet of it here, this image on the right that we got from CISA. Have the link down there at the bottom if you want to see a little more about it. With this, we hypothesize that Volt Typhoon will attempt to obtain credentials via either obtaining the ntds.dit from our domain controller, which is what stores your hashed passwords. It's going to run VSS admin to create a shadow copy, and it's going to use ntds util to copy that ntds.dit file over for some reason. We'll talk about that here in a minute. So the first step is we're going to create or curate some detection rules that we think will help hit on these TTPs. So to do that, we're going to head over to Sigma. We have this Sigma rule that we think will match on our hypothesis. The rule is going to detect on some command line arguments related to retrieving ntds.dit. So we can see here that it's really looking for only these command line arguments. So if it's running this VSS admin delete shadows, create shadow, trying to copy the ntds.dit folder or file around, if it's trying to save the system hive, which is where ntds.dit exists, and some other ways they could try to ascertain that. So utilizing Sigma, we can quickly translate this detection into our query rule here. This is what I was trying to show you guys earlier. Basically paste the command on the left. You choose Splunk up there under the back end, and in the right, it will give you the query that you're going to hunt on. This query I'm seeing now is exfil through 7-zip, but it's the same way regardless of what the rule is. You just put it on the left, you choose your back end, and then on the right, it'll automatically translate it. All right, so we took that rule, or we took that detection, we pasted it into Splunk, and we see that we have some hits on our hypothesis or the Sigma rule. So I will preface this with saying that hunting through the seam is kind of more of an art than a science, I would say. Just because you have hits on something doesn't necessarily mean that it's malicious activity. Right now, we just have anomalous behavior that matches on a rule that we have. Lots of things can be explained away. This could be normal activity that maybe an administrator is going through and creating shadow copies or backups of ntds.dit, things like that. So right now we just have like some anomalous behavior, but we're going to get more into that here in a second. You want to, excuse me. So like I said, right now the only thing that we know is that this hits on our rule, but we don't want to stop there. We don't want to sound our APT discovery alarm. We don't want to isolate all the machines. We don't want to call in our incident response team or the FBI to have them come in and try to, take over and see what's going on. We need to further investigate and triage as necessary. We want to create as much of a picture of what's happening as possible before we go ahead and hand it off to someone else to escalate. Right now, we don't really know too much of what's going on. You want to make sure that you take notes of this anomalous or malicious activity so you can later piece together what's happening. You can quickly become pigeonholed or foxholed and kind of forget the previous information that you've seen due to like when you're hunting, there's so much information, there's so many rabbit holes that you dive into. You want to make sure that you document things as often as possible, even if it's just a screenshot like this with like one or two lines in there that provide some context into what you're looking for. You need to document what's happening. But with all that being said, back to the hunt. What do we see here, and does this warrant additional investigation? What do you guys think? Based off of what we have here, we see that minimize that. We see that the parent image of hunt.exe, which is running out of this administrator campaigns directory, that's an odd place. That's an odd place for something to run out of, right? And then that hunt.exe is spawning CMD or command prompt. It's spawning VSS admin. It's running those create shadow copies and things like that. It's trying to create a shadow copy. It's trying to then move the ntds.dit over to a temp directory. So I would say it is definitely anomalous. It's very strange, something called hunt.exe. That's an odd name for something to run. And the directory it's running out of is also very strange.
I'd say it's a little suspicious.
It's a little suspicious. I agree 100% with what you guys are saying in the chat. And exe in this location, my like general rule is if an executable is running outside of program files x86 or system32, it should be investigated, right? You shouldn't be running stuff out of temp, out of downloads, or there should be minimal things running out of temp or downloads or public or directories like that. You should really, if it's not in program files or system32, you probably want to check it out. So we could, right now, this is just the screenshot, but we could go into Splunk and pull the hash of that file out. We're gonna talk about that later in additional steps to take. But yes, that is a great idea to grab the hash of the exe. We could plug it into VirusTotal. You could search if, or you could see if it exists anywhere else in the enterprise or on your network, things like that. Grabbing the hash would be a great step. So we all say that there is enough here to warrant additional investigation. So let's move along. So for that, the next step I would do in an investigation is look for events that are surrounding this anomalous behavior, right? So in Splunk, you can do it pretty easily. You just click on the time of the event on the left. A little pop-up will appear, and you can give it a time range. I would recommend probably starting at like 30 seconds or so, maybe 2 minutes, a small amount of time just to kind of get a better picture of what's happening around that event. Is it performing other actions? If you look at it like a timeline, like a tree, if you have something hunt.exe that then spawns 15 different commands, that's pretty abnormal, right? And that's kind of what we're seeing here. We see some more anomalous behavior. We see discovery commands being ran. We see that hunt.exe is the parent process running out of that uncommon directory I was talking about. So we'll note that. We'll keep going. Again, for the initial investigation, it's fine to have screenshots like this and just provide a little bit of context. Have one or two sentences above or below it. Like I would have here that hunt.exe running out of C users administrator campaigns is executing command prompt and PowerShell commands. It's running network discovery techniques such as who am I, net start, get net neighbor, things like that. You want to make sure that even if you have the screenshot, that you provide some context, because looking at just screenshots can be very, very difficult to piece together once you have a few days break from looking at this, or even like an hour break. Maybe you go get lunch or something. Looking at just the screenshots, you kind of have to reformulate everything that happened in your mind. So provide as much context as you can. And if you don't believe me, run one of these exercises, close your OneNote or your Notepad document, go walk around for an hour, and then come back, try to piece together the same you had in your head. It's not going to work. It just isn't. Um, so the next step, I'm going to modify our query to look at the parent process of hunt.exe. That seems to be where things are happening from, or at least a point where a, at least a point where most of the anomalous activity is coming from, right? So I want to see everything that hunt.exe spawns and any of the command line arguments that go along with it. So in here, what do you guys see that jumps out to you? Something that is an immediate like we need to get on this quick. I would say for me, I would say for me, just the sheer volume of discovery commands is pretty odd. But again, anomalous. Some people are command line people. I turn my computer off via command line. Maybe that's weird. But the discovery commands are weird. But then yeah, like Michael said, definitely that shadow file. Creating a shadow file, and then pulling the ntds.dit out of it, which we can see down there at the bottom, and copying that into a temp directory is very, very odd. And then you see further down, thanks M Wyke. And then we can see further down that it's running that curl command, which would definitely stick out to me. Any kind of curl command executing on a system via like command prompt or PowerShell or things like that is not typical user behavior. People don't use that. Um, it's very, very, yeah, people don't use that as general context. That's really just to kind of hide and live off the land for probably exfiltration, I would say. So we see here that it's trying to curl up that ntds.dit that we copied over into the temp directory up to a website called file.io, which is an open file storage site. It's really useful to use for exfiltration. I would probably have that blocked in your firewall, not allow people to get over there. So yeah, we see some stuff here, some pretty anomalous stuff. One thing that's also pretty strange is that get event log security 4624. This is something that we have seen in Volt Typhoon's CTI, where instead of them trying to enumerate valid users via like maybe get tag local user or get tag AD user or something like that, um, they actually just query the event log for 4624, which is successful logon, and from that they're able to figure out who has logged on recently. Which should be indicative that this is still a valid account, and who was able to log into this system, which also should give you a pathway into what users might already have a profile on there, what users typically use this machine. If they're connecting via RDP or something like that, you could also see that based off of the logon type 10 for RDP. So it can give you a lot of information in this, and it's also kind of a novel way to discover that, because the only thing I typically look for or care about in event log is if it's being cleared, right? I don't care if people are looking in the event log. That's kind of an odd detection to have. So in this case, we're kind of taking advantage of typical defenders' behavior, that they wouldn't look at something like this and immediately be triggered. There's probably not an alert for a user running get tech event log because it's pretty innocuous, right? So that also stands out to me.
I
And
don't
then we're
think
still,
people appreciate how much or how stealthy that piece of discovery behavior actually is. Because nobody cares if someone's looking at their event logs. You just care that they're there or that they're being logged properly and correlated and sent where they need to go. But
Mhm.
someone actually querying it's like that can easily just be overlooked. Like, oh, that's just Joe Schmo validating logs are
Yeah.
happening or something.
Well,
And
and
it's avoiding all common detections currently because we're looking for PowerShell or command prompt commands being ran. We're looking for specific tools being used. We're not looking for people looking at your event logs on host.
yeah, no, exactly. Be like, and you also too, your event logs have a lot more information. They should have your SMB shares in there. They should have what you're mounted to. Users trying to log on, when they logged on, what times. I mean, there's a lot of valuable info in there, and for the most part, like you said, we don't really care if people are looking at it typically, because it's it's whatever. Where something like "Who am I" might stand out to someone. querying that event log probably is not going to. So we're still focusing on that parent image of hunt.exe. So the next step, so we know now what processes it created. We excuse me. We know what processes it has created. We know what it's running out of. We know some of the commands that it's running. So now that we have kind of the host-based activity, we're going to switch over to some network activity. So while we don't have an NSM that is running in our lab via Sysmon, we're still able to see what DNS requests, what DNS queries, and what network connections it has initiated via event codes 22 and 3. 22 is DNS and 3 is just network connections in general. So we see that hunt.exe is reaching out or is doing a DNS query to training.stage.unicorncroft.com, and it is doing a network connection to that 3.128.209.240. So I think at this point, it's probably pretty safe to say that hunt.exe is malicious, more than likely, and requires an enterprise hunt of sorts. We also see what its possible C2 that it's reaching out for here on this page is training.stage and this IP address. So we want to go ahead and document that as well.
So you got a question in here, Tyler, of like how could they check or potentially validate whether these behaviors we're seeing are human interaction or just system executed itself?
Hmm. So one of the ways we see human interactions compared to automated steps is if we see typos in the command prompts, that's normally a pretty good indicator of that this is a user doing it. You could also look at inside of Splunk, look at the user. It'll tell you if it's system or if it's administrator or tray.b or whatever it is. But that's something too that's not really, I don't have a great answer because you have to investigate
It's
and
context
determine.
dependent.
Yeah, it's really kind of using what is normal to you and what you would think of as normal, and if this is normal or not. So like, let's say that we get an alert from someone that says like, oh, this software has been installed or something like that. You could go in, look at the software that's installed or the parent process or the image or parent image of what they are concerned with and pull the hash from it. You can check if it's a valid hash, maybe from Microsoft or from something like that. You can see if it is, if anything in VirusTotal gives you any hints to it, but it's really just based off of the contextual information of what else it's doing. So in this next slide, I have all the stuff of what we know. So we know that PowerShell spawned hunt.exe. To me, that's a flag immediately because hunt.exe is not in a typical directory, right? Anything that's running by system or like installers or already installed software, again, should be running out of either program files or system 32. If it's not in, or program files x86 or system 32. If an executable is running not in those directories, that is an immediate flag for me. That is one of the first things that I look for whenever we begin our hunts, and what I tell people during our purple team engagements. The location matters. If you're running something at a temp or public or downloads, brother, you got a problem. You got to check that bad boy out, Then we see what else we know. We know for a fact that hunt.exe executed who am I at that time. It executed net start, so they want to see what processes start when your machine turns on. So that'll give them indicators into what EDR you're running, what security tooling you have running, antivirus, things like that, Word, other things that start immediately, Teams. It can let them know what processes are going to be on no matter what. And then it gets into that get tac net neighbor, which is kind of like the PowerShell equivalent of ARP and
Our
test connection all in one. So it'll tell you what machines you're attached to and if they're reachable or not. That's not super abnormal. Like administrators should be using that, or maybe you're doing some troubleshooting. But together with everything else, that just looks like more discovery commands. Maybe trying to get an idea of what machines you're connected to, and you couple that with the get tac event log 4624. Now you know what machines you're connected to, if they're reachable or not, and what valid users are logging into those machines, right? So those two things together, that's pretty odd. Then we get into the VSS admin and copying of the NTDS out of that shadow copy that we just created into the temp directory. And then we see that the file.io curl at the bottom, all of those things are indicative of malicious behavior. This should not be something that's done more than likely by a valid user or administrator or things like that. Or if it is, you can look back in the logs, see who did it, and just call them. Be like, hey, Joe, I see all of these things. Are you doing this? And they could be like, yes, I'm doing it for whatever reason, or no, that's not me. And then you have even more fidelity that what's happening is malicious and needs to be investigated. And then lastly, what do we know? We know that we see connections, more than likely the C2 connections, the command and control connections over to training.stage and that 3.128 IP address. So in here, I think we have enough. This is a very short kind of hunt scenario because we're going to get into a little bit of a more in-depth hunt in the lab here in a minute. Just a quick scenario of how to utilize what you know and what's anomalous and pivot what you know and what's anomalous and go off that to provide more context and more information. Yep, and 4688 and sysmon1 is great. Those are process creations. I like to use sysmon more than the security log just because I feel like it provides some more information. But in lieu of having sysmon, utilizing the tools that Microsoft provides you with is great. Security log has a bunch of information in there. The system and application log, really not so much, but the security log, 4688 for process creation, 4624 for logon, 4625 for failed logon attempts. If you see a bunch of 4625s of the same user account and then a 4624 that user has logged in, you got brute force right there, right? Things like that. The event IDs, so we get into that in the labs, but the ones I like to look for are, again, inside of sysmon, it would be event code 1, which is process creation, 11, which is file creation, 3, which is network connections, 22, which is DNS requests, and then 12 through 15 are registry key related. So I like to look at those are probably the main. I stopped counting, but probably the 5 main ones that I like to focus in on. And then again, I have it's in the manual. We'll get into. I'll show you kind of, I think a better way to figure that out. But yeah, we'll get to that here in a minute. Excuse me. So we did. 1 second. All right. So we've gone through our investigative process. We think we have a pretty good start. We're going to escalate it up. Now that we've done those, now's the time to go back and kind of refine what we're looking at. Can we create any new detections based off what we've seen? Can we employ that Sigma detection for the VSS or the NTDS.dit interactions? We'll call it. Can we employ that? Is that a good detection for us to employ in our environment for us to be alerted on next time to have a reactive kind of hunt versus proactive? Like, we know if we see this, it's bad, so we want to have an alert so we can know about it as soon as it happens. And then do we have any gaps in visibility that are hindering our ability to identify any kind of behaviors? Not really so much in this small hunt that we did, because it's a very simple one. But when you have larger hunts, you're going to have gaps. It's okay if you don't see everything. You should be able to piece together or hypothesize the missing pieces, and we'll give you kind of a way forward and how to do that towards the end using the MITRE ATT&CK navigator. And then overall, excuse me, so sorry about that. And then overall, we want to see how we can use this hunt, even if it was anomalous and not malicious. How can we use this hunt to improve our future hunts? What are some ways we could improve, some queries we could improve, some false positives that we can exclude to reduce the noise and things like that? We want to reflect on what we've done and improve upon it. So when we do it again, it can be faster, better, stronger, right? Higher fidelity alerts, less noise, quicker to discovering malicious or anomalous behavior. It doesn't make any sense to go through all of these steps. Hunting is time consuming. It can be difficult. You don't want to keep repeating the same thing the same way you want to continue to improve and move forward and do it in a better way, right? All right. And then we have what I like to call the Easy Wins dashboard. If anybody is on on this webinar that knows me, I am not a fan of dashboards. I think that dashboards can be a crutch if you don't understand what they're doing. They're very, very useful if you do understand them, but just looking at a dashboard in and of itself, I'm not a huge fan of. But with that being said, we have some easy wins, some low-hanging fruit that we have here. So the first one, we have if anything is executing outside of normal directories. So again, if anything is outside of program files x86 or system32, it's going to show up with that suspicious CMD or posh command line. Posh is PowerShell. And this dashboard should be in our lab. If it is not, I can actually send you guys the XML for it so you can have it to employ in your environment. And then the next one we have are suspicious run key values. That again is looking at event codes, I believe 12 through 15 in Sysmon, which is registry events, registry set, registry delete. So we see here that there are some run files that were being manipulated or changed. Suspicious process creation location. That's a lot to say. I don't think I could say that 5 times fast. That is off of, again, executing out of abnormal directories. Temp, downloads, user profile, public, etc. I want to be alerted to that. And then the last one is suspicious command line or curl or DNS queries. So if PowerShell is probably going to reach out to the internet to pull updates, right? It should be going off to Microsoft or Azure sites though. So we're seeing here that we have some telegram.org, ipinfo.org, which is commonly used by adversaries to ascertain what your public IP address is. We see that CMD is going out to Google. That's weird. We see file.io from curl, some FTP and share.sh from curl. Those should be investigated. You don't want, adversaries are living off the land, utilizing the tools that are available to them without having to perform ingress tool transfer into it. Those tools you want to be monitoring. They are easy wins. There is almost no reason why those images or those processes should be reaching out to the internet, especially not these sites. And then that takes us over to state-based detections. I actually think that these two should be switched. I'm going to do it this way. Forget that one. We're going to look at keyword detections. So keyword detections, which I think we hit on in the chat not too long ago, can be pretty easily bypassed, right? So there are so many ways for an adversary to achieve the end result. The end result for this is trying to query they're trying to figure out what user they are, right? So we see two different examples of how they could do it over there on the right. The first example is you echo the environment variables for user domain and username, and that's going to give you what domain or what machine, if they're not on a domain, what domain or machine that adversary has control of, has a shell on. It's also going to give you the username of who they are. So we can see that it's an EC2 machine and they're running as administrator. If you run who am I, it gives you that same info. But if you look on the left, if we search for who am I, just doing keyword searching for whoami.exe, you don't see the first one. So while the adversary or attacker has the same results, they get the same results in the end. They know what machine they're on and they know what user they are. It looks different to you as a defender because we're not looking for those environment variables being queried. Does that make sense? So yeah, so say that to go over to the state-based detections, which are a higher fidelity way to hunt for activity. So they might be running things in a different way. They might be running things in memory or some other ways where it's not logged the way that you would think it's going to be logged. So in here on the top left, we have our command that we ran in site using the upshell module, which is unmanaged PowerShell. So that utilizes the system management automation DLL. Right? Did I say it right that time? I almost always get the order confused, but it's basically it's running PowerShell by calling the PowerShell DLL and not running PowerShell.exe not running PowerShell.exe explicitly. So we see that it's going in, it's making this new scheduled task called Xbox Microsoft underscore Xbox U. And our query on the top right, you see, we're looking for just the command line way that an adversary or a user would do that. So we're looking for that new scheduled task action, scheduled task create, all the different ways that you can create scheduled tasks using the command line, but we don't have any results returned. The reason for that is that upshell, again, runs in memory. The command line arguments of things that run in memory are typically not logged. You would need an EDR or some other kind of in-memory tool to see those things. However, it still has to, when it creates that scheduled task, that task is written somewhere, right? In this instance, we have the query down there at the bottom where we're looking for the target file name inside of either Windows tasks, Windows System 32 tasks, or Windows Syswell 64 tasks. The reason for that is when you create a scheduled task, it writes that scheduled task in one of these three directories. It 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 has to. So even if an adversary runs something in memory, if that action is written to disk somewhere else, we can still detect it and prove that it happened. So it applies to more than just scheduled tasks. It could be services being created. It could be run keys being modified. It could be anything. If they're modifying something on the endpoint, which they're probably going to at some point, other than doing maybe discovery actions, because those might not be logged. But if they're changing the state of your endpoint, it's going to be logged somewhere. So don't get kind of pigeonholed into um, don't get pigeonholed into just, is this command line value logged? Because if you're working with a high level adversary, a nation state actor, or somebody that exists really only in memory, those keyword detections will not work. But the state based detections, you cannot move around. It has to be written to disk somewhere. It's even like when you look at if someone clears Windows event logs, all those logs might be gone. Hopefully, you're already sending them to the SIEM, so it doesn't matter if they clear them locally or not. But if they clear all of those event logs, the last entry in your security event log is going to say event logs cleared. There is some evidence that those actions happened. You can't erase everything from disk, because even when you do erase it from disk, it's written somewhere else saying that you deleted that, right? So you want to, as much as possible, utilize these state-based detections. It's going to give you the most fidelity, and it's going to give you it's really the best way to be sure if an action did or did not happen. Oh yeah, Trey has it with the run keys, but if you guys didn't see it, the run keys are registry keys um, that will execute a program or I'll call it a binary. It will execute something when the system turns on or a user logs in. So these are supposed to be used for um, like having certain things turn, like your EDR. Your EDR might have a run key where when your system turns on, it launches that EDR program or something like that. But you could also use it as a mechanism for persistence. So if you have a callback or maybe like that Scythe campaign that we downloaded and executed, you could have your registry keys set to have PowerShell launch that executable, and that way you would get a check-in every time that the computer is either turned on or that user logs in. So yeah, you definitely want to monitor those very closely, and if you see any new ones pop up that are not explainable, you definitely want to investigate that. But with all that, that's going to take us into our individual hunts. We'll probably give it about 15 minutes or so before we check in on you guys, just because we're kind of running a little tight on time. So we'll check in and do it. If we can't get all the way through it, I'll kind of go through it, and you guys will have some extra time to go through it on the end, because after we do the hunt, we'll talk about reporting, and I want to show that. So we'll give it about 15 minutes, 20 minutes. If you guys to go through, we'll field some questions and stuff, and then probably move on. You guys can get back to the hunt after that. So yeah, if anybody has any questions or issues that come up before then, please let us know. And yeah, say David, I'm looking. Oh, David, your Google page popped up and now it's deleted. Yes, Hamaz, yes. So the run keys are be either the run or run once. The difference with that is that the run keys will exist until it's deleted, and the run once key will execute one time and then delete itself. If sure, so we'll give you guys, like I said, about 10 minutes. Yeah, we'll see you in a little bit. But I was seeing some having issues on the log, so I'm gonna just hop in there myself and see if I get the same thing or not. Yeah, the host name and exe name that are in the screenshots are likely or are different than what we have on our machine, but the queries and stuff should be the same, but the host name and exe name should be different. The exe name should be h1.exe or whatever you name that second campaign when we launched the Lockbit one. So the screenshots are different because we make the screenshots outside the lab on a different machine. That way it doesn't give all of the doesn't give all the answers exactly away as you're going through it. But give me a second, I'll get Splunk and everything loaded up and see if I'm getting the same issues that some of you guys are getting. And again, if some of the steps failed in the campaign itself, that is more than likely fine. Some of them are kind of not designed to fail, but fail just because our endpoint doesn't have all of the same software and stuff on there. So it's not a big deal if it fails. The command line actions should still be logged in Splunk. Just wait a second for Scythe and Splunk to come up. All right, so index equals main, source equals when event log system not when event log system operational, when event log security. It should be, and then event code equals 1102. And then you should have your time picker set to all time and no events. That is weird. Hmm. See if the campaign executed all the way through. Hmm. Okay, I see what the issue is. I apologize for that, everybody. I had a little bit of a silly brain, as they say. So the event log clearing is in the lock bit with this time added on it at the end. So we need to make sure that we execute this lock bit and not just the lock bit v3 to get it in our logs. So we could do create campaign, lock bit v3 underscore 2. Yes, if you go back into the lockbit v3, or create a new campaign with the lockbit v3 threat that has the date time group after it, the lockbit v3 tac 2024 tac 11 tac 01. That one actually has the event log clearing. That must have been what I added into it. Sorry about that, everybody. This is the first time that we've run this lab, so I apologize for some of the hiccups. That will have, yeah, go into that one and execute it. I would go to step 5 and delete the lockbit mutex, and then you could see down there at the towards the bottom that it'll go in and clear the event logs. So if you ran the one that was just lockbit v3 and not the one that was lockbit v3 with the date time group, I would go ahead and just re-download or create a campaign with that one, download it, and then execute that one. Change the name to, I'm going to call this one h2.exe, and then run as administrator. Sorry about that, everyone. Yeah, and again, if you see some of the steps that fail inside of the campaign itself, it's no big deal. Those actions will still get logged. It could have just failed due to like the transfer.sh. That does not always, it doesn't always work. The site is very finicky with whether or not it will accept it. That's why we've transitioned most of the threats to file.io because it works a lot better. And then where we select the data group. So that one, Andrew, if you go to create campaign, you can give it whatever name you want, and then add existing threats, select existing threat, scroll down to the L's, and then do lockbit v3 with the 2024 1101 date time group. Add those steps, and then go up to step 5 and click those 3 dots, click delete, delete step 5, and then create your campaign, and then you can download it from there and execute. And give that a few minutes to run all the way through, and then we should see it. Sorry about that, everybody. If you want to skip over, excuse me, if you want to skip over this part of looking at the event log, just kind of put your blinders on and believe. While it's still running, you can go in and execute the rest of the stuff. We focus on the events surrounding that action as well as the parent process. But I'll give it a couple minutes for this to run through, and then I will walk through this hunt.
Hey, Tyler. Never mind, you're on it.
Ish. So the campaigns will become inactive because we have at the very bottom of the campaign the controller shutdown. So the controller shutdown will literally shut down the implant on the endpoint. So then once it's killed, you can't interact with it anymore. If you want, you can delete, like when you create campaigns, you can delete the controller shutdown at the end, and then you'll be able to still interact with the shell and things like that. Oh, thanks, David.
Everybody doing all right so far otherwise? Any other issues popping up?
Yeah, and as soon as my campaign gets to the point where it clears the event logs, I'll hop in and we can demo some of the stuff so we can get to moving on. So it should just be the event logs is at the end because obviously an adversary would want to delete everything that they're doing at the end of it and not in the beginning. So it just takes a few minutes to run all the way through.
Hey, nothing wrong with that, Courtney. When it comes to training and stuff like that, you gotta get it in where you can fit it in, right? Not a problem, Andrew. That's what we're here for. The whole point's for everyone to learn, so we don't want to just leave you in the dust.
Yeah, like I said, this is our first time that we have run this lab. So if you guys have any feedback or anything that you would like to see improved on it or additional things or something, or definitely think our first bit of feedback for us internally is to extend how long this lab is. It took a little bit longer than we thought it would to get through it. But if you guys have any kind of criticism or things or feedback you would like, please shoot it our way so we can improve it for future iterations. Just waiting for.
Yes, we will have other sessions. We typically run workshops once a month throughout the year, and the topics vary. So, like 1 month it might be like this one, hunting through the SIEM. The next it'll be threat emulation. The next it could be about starting a CTI program. It all just varies. The best places to check us out on social medias or at the website under our workshops and events tab, and you can see what's coming up. We are going to take December off to give us some time to revamp and update some of the labs we have, but we will be back at it again in January hosting more workshops. Tyler, did you see Carson's note?
Yeah, I'm looking at it and now mine is. Also failing out on that one. It says I have too many arguments, which is odd because it ran just fine when we tested it. I'm looking at it right now. Yeah, I'm getting not sure why it is failing on that one. Let me, for the sake of time, I will demo real quick. Yeah, another one. So yeah, I'm also getting that too many arguments were specified. What this command does is it will pull all of the event logs that we have on the system and then iteratively go through each of them and clear all of them. There must be a limit set to it. Not sure why it's failing because we had it set before. But nevertheless, I went into the shell and just cleared the security log, which had worked. So what I'll do is just kind of demo it from there. Was kind of put our lab, our lab eyes over it and continue on that way. So sorry about that, everybody, but the rest of the steps, other than the time, should all be the same for all of us. So let's get in and demo. All right. So in here, let me switch this back to event code equals 1102. Yeah, so in this hunt scenario, we have received an alert from our SOC that our Windows event logs have been cleared on the Unicorn box. Thankfully, our logs are already being sent to the SIEM, so it doesn't really matter that the event logs were cleared on the endpoint, because we have them all stored in our SIEM, so we can hunt for it from there. If we didn't have our endpoint logs or our security logs, security logs forwarded to our SIEM, we would be not in a good place, right? So we'll go over to our SIEM and we're going to try to figure out what's going on, right? Having your Windows event logs cleared is abnormal. So let's go in and figure out what else is going on. So I was able to go in and look in the security log event code 1102, which is Windows event log cleared. Look over here, you can see just in the interesting fields, the account name, computer name, what index it's in. We want the message. So the message is the audit log was cleared, gives us the SID of who did it. The account name is Unicorn, domain name Unicorn Labs. So looks like our Unicorn user has gone in and deleted out or cleared our event logs. So let's see what else is going on. Again, make sure you set this first one, once it runs through, or if you open the shell, you can run this wev util clear security log, and you can get the same log into it. So we're going to see what events are happening, what else is happening around this time frame. So to do that inside of the events here, just click on time, and we can set how many seconds plus or minus we want it to look at. Because this, I had to kind of re-go through it. I'm going to set it to 5 minutes or 10 minutes. And we need to go ahead and change our event code. So right now it's only looking at event code 1102. So the only results we'll get back are this event log cleared. We don't want that. I'm more interested in what processes were created around this time. So I'll go ahead and change this like we have in our manual. See if the paste works. So event code 1, stats, values, command line by image, parent image. Search. Let's just, something wrong with the time again. That's okay. We'll just set it to all time. And we'll do all right. So we'll go off the images for this one. I'm not sure what is happening with the first initial ones, but anyway, so we'll go in and we'll go off of this query that we have here for event code 1, values command line, and we're going to look at the image and parent image. So what this should do is group together all of the command lines that are ran by the same image and the same parent image or parent process. So just looking at it quickly, we can see some Splunk stuff happening, which is totally normal. We see the WEVT util going in and attempting to clear all of our event logs. And then we can see down here all of these other event logs that we have. So definitely some suspicious activity that we see over there. Have another screenshot here where we look at the same thing. Come on. My screenshot's not going all the way down. Okay, so in here, yeah, sorry that the SIEM stuff is that this initial SIEM stuff is acting up. I'm not sure what's going on in the lab here, but in here, as we look through, we could see that surrounding these events, we have the same kind of parent image that is abnormal, that is launching from a weird place. So let me just change this around real quick. You might notice when you do some of the stats commands that it is it'll put the tables in kind of a weird order, so you can do a table afterwards and give it the order that you want those fields to kind of show up in. So we'll go in from our time-based one. We're able to see that this h1.exe.exe seems to be the parent process of a lot of the parent process of a lot of these command line parameters that are very odd, right? So we see that h1.exe is running arp, netstat, route print, lots of discovery commands. We see that it's doing some archive compression in here. It's making directories, it's deleting stuff, it's trying to upload a file via transfer.sh. This is a zip file here. Some more discovery, such as the IP config, net accounts, all the stuff like that. See, it's trying to clear those event logs again, and it has that who am I /all. So in here of the stuff that we have looked in, again, we kind of have to pretend that the time part worked. Sorry about that. That the time part worked, and we identified this h1.exe running all these strange commands, right? So from us seeing those strange commands, we're doing just the same that we did in the slides, where we're going to focus in on that parent image and see everything that it's doing. So based off just these quick 2 searches, we were able to see that the event logs were cleared. We're able to see that they were cleared via this WEVT util, and we were able to see that h1.exe seems to be the spawning point of all of this activity. So from this point, do you guys think that this is enough to continue on in the investigation and try to figure out more of what's happening? Answer for that should ideally be yes, because it is, again, just the same like we saw in the labs, running out of that strange directory or abnormal directory. This is running out of downloads, which likely means that somebody downloaded this from the internet or something like that, where the default of it would have it being sent to the downloads directory. So then we'll move on to the next one. So we want to see what else h1.exe did. To do that, we can copy this command from over there and paste it in here. I need to put another asterisk right there because I named mine h1.exe.exe. And we can go in. So we're going to look for the parent image or image of h1.exe. We're going to put asterisks on either side to account for that extra exe that we have. And we're going to do a stats count by event code task category, and we're going to sort by the count. So the reason that I like to do it this way, this kind of goes back to when we were talking about what event codes are good to look in, where a lot of valuable data is. Once you have it kind of set to close parameters, such as just the image or parent image, I like to just do a count by the event code and task category. So that will tell you what event codes interacted with this image or parent image. So we see that h1.exe either as the parent process or process was executed in these event codes. So we see that it modified some registry values, it created some files, had network connections, process creations, DNS queries, and a process terminated. So from there, we know that if we want to see more activity for the h1.ex1, h1.exe, excuse me, we want to look inside of these event codes. And I like the task categories because sometimes it's hard to, you don't want to memorize all the event codes. So the task category, again, just provides you with some more context. So again, down to what we know the event logs were cleared. We know that h1.exe was the parent image that spawned the event log clearing. We have the command that it ran right there underneath it. And we see that h1.exe is the parent image or image in the below event codes. So we can use these event codes that we found to pivot into what that executable, what that binary was doing. So the first one that I like to look at is event code 1, which is, again, process creation. So we do event code equals 1, very similar to what we had before. And I will do a stats values command line by parent image, and then I will table out parent image values command line. It's probably the most common one that I use for the stats as far as process creation is involved. I want to know what spawned it, what the actual process is called, and then what command line parameters it has. You could also include parent command line, but I think that gets it kind of, a little too much stuff in there, right? So it doesn't look quite as nice when you have it in there. So I like to just kind of leave it at these three. You don't want to have too many fields in your stats command because it can be, it just has too much data in it and it doesn't look as clean. So again, we're looking down here. You can see that it was launched via Explorer. So that is this file explorer here. That means that somebody either clicked on it, that it didn't run on its own. It had to have some kind of user interaction for it to run. So that means that somebody clicked on this executable, which then launched. See that it looks like it also executed this am base patch1.exe, which is interesting. Those discovery commands, it launched PowerShell. We could see exfil.zip created some directories, compressed a directory. It deleted some shadow copies. That exfil attempt via curl up to transfer.sh. That's something that we should look at. Some more discovery ipconfig, and then this event log clearing, which we already know. So kind of a lot of stuff that we've already seen in the previous commands. Just trying to get a full picture of everything that it has executed so we know everything that it's doing and see if there's any other points that we can pick off of this to kind of expand our hunt, right? So over here, I like to keep track of what we know. This is my version for the lab of how we're going to keep our notes of what's happening, right? In a real investigation or a real hunt with your team, you probably have some kind of tracking software or utilities that you use, or maybe it's just OneNote. That's what we used to use. We had a small team. It works great. You can put images and stuff in there and context. You can collaborate at the same time. But for the sake of the workshop, I just have it over here on the right. So we have a list of all the commands it ran. That h1.exe was the parent process of it. We know what event codes it was in, and we know that the event logs were cleared, which is what started our investigation. So from there, we've looked at process creation. So let's switch over to file creations. So for that, we're just going to go ahead and switch event code to 11. Going to get rid of that. And then I will just run this as it is. We see we have a bunch of entries come in. Say maybe you're not familiar with what fields exist in this event code, and you want the easiest way to kind of look at what fields you might want to see is just to run it and look at the interesting fields on the side. So in this, I want to know what the file names are of what it created, and I want to know what image created it. So what I'll do is a stats values target file name by image. And this will kind of clean up some of that stuff that we were seeing. And just it's a lot cleaner and a lot easier to see when we do it this way. So we see a lot of these target file.docs that have this .lockbit extension, which is indicative of some kind of ransomware. The .lockbit is what the lockbit threat actors will put on the end of the files once they encrypt all those files. We also see that it has a README, which is also indicative of ransomware because they have that note that pops up, which should have popped up on your machines down there towards the end. But we'll get into that here in a minute. And then we see at the top here that has this PS script policy test, that it has two of them. That is indicative that it ran some kind of PowerShell. So the PS script policy test is PowerShell checking what its execution policy is. So when PowerShell executes from an executable, it will create these temporary files in there. That's PowerShell literally going in and seeing what it is allowed or not allowed to run, right? So we see in here in our notes, we have about 205 files. We got 203 over here that have been renamed to target file doc with a number and then the dot lockbit, which should be indicative that our threat actor is the lockbit threat actor ransomware group. Then as we go down, you guys can read through all this again. I'm sorry that I'm kind of speeding up through this endpoint here. But we also see during this, while we're doing our investigation, that the end user that had this machine that had h1.exe run on their system has alerted us that they have received this pop-up that looks very much like a ransomware note, just lockbit v3 on there. So we have more confidence that this was a lockbit v3 threat actor that has attempted to or successfully performed ransomware or lockbit ransomware on our endpoint. So at this point, it's definitely enough, I would say, that this is malicious activity. I would give somebody what we call, a warning order, like, hey, we have this activity going on. I'm still performing my analysis on it, trying to figure out everything that's happened and who is affected. But can you being the intelligence team or someone else on the defender team, can you look into lockbit ransomware and pull some more TTPs, pull some more procedures, pull some more things that I can look for to try to identify this, to be able to completely have a picture of what's going on, right? So from this, we've been able to add in that h1.exe has modified the files in the lockbit v3 directory. It added the lockbit file extension to each file name. It modified approximately 100 files with this .lockbit extension, and an end user has reported that lockbit v3 ransomware note has appeared on their machine and their files appear to be encrypted. I don't remember who asked it earlier about if we could run the lockbit v3 on this endpoint. How we do it with all of our threat emulations is we will create the directory. Lockbit v3 is what we're calling this one. We use a file module to create these dummy files, and then we encrypted those files. So when we run these emulations, we're not performing ransomware on your actual endpoint itself. It's just specified to this one directory, so that way it doesn't disrupt or break anything in like your production network. And moving on, the next one that we want to check out again from our list of all the event codes that h1.exe has interacted with, the next one on our list is the registry events. So we can go in, we're going to change our event code to 12, 13, and 14. These are the registry, or these are the sysmon event codes for registry events, modifications, and deletions, I believe. Go ahead, we'll change our stats because the fields are different to values of target object by image. So in here, you see that h1.exe has interacted with all of these registry keys. So if you are looking at these registry keys, you can see that they all seem to start with the same thing. It's all software, Microsoft Windows, current version, WinEVT channels, and then the name. Does anybody know what these are or what this is indicative of, or what they're trying to do? So all of these are excuse me, all of these WinEVT channels are Windows event log channels that they more than likely what they're trying to do is disable these, right? So we can see that all of these registry values, they all end with enabled. So in here, it would require some more investigation to see exactly what it is. You could go onto the endpoint itself and just query one of these registry values. But at this point, we can hypothesize that they are setting the value of this enabled to 0, which will then disable that. It will disable that event log, and it will not create any more logs. So when they go in, they've deleted or cleared all of the event logs and then disabled all of these event logs from creating additional logs in the future. So we add that to our list. Down here at the bottom, we can see that it's set over 1,000 registry values, and they're all inside of this WinEVT channels directory itself. Asked if we can dig into the edited value. Let me see if it'll show it in this one. I don't think so. I think to actually see the value that's being set, you would have to have command line visibility over it to be set, or you would need to modify your sysmon configuration to include that value. So that value is not included currently in our lab. You would more than likely need to either go to that end device itself or do some kind of remote management or something like that to go in and see what values were being set. But we know that they were modified. The IDD word. Let me see. Oh, yes, exactly. Had a little bit of silly brain over there. Yeah, so the D word here is what they're having it set to 0, which again will turn this enabled, which would be 1 to 0, which will effectively disable it. Thank you for that. Then moving on. So we know in that one that these registry keys were modified. We're able to see that the lockbit directory has been encrypted. It's got that .lockbit there at the end of it, and we have all of the parent, or we have all the processes that were spawned by h1.exe. So then moving on to our next event code is going to be those network connections or DNS requests. For that, we're going to copy these over very similar to how we did it in the lab. exe. We're going to that, and then we'll do a sort minus count. And code in 3. I gotta add the asterisks on there. All right, so in there we can see that our image of h1 or parent image of h1.exe has reached out to this 192.168.0.101, which is a local host, but again, a little bit of labism, a little bit of gameism. This 101 is our scythe host, which is our C2 that we have here. So we see a bunch of connections going out to that. That's something that should be investigated, as well as this 199.59. That's something we should look at and see if we can figure out what that IP address is related to, what it's seeing. And then if we switch from 3 to 22, the DNS requests, and change the field values to query name, that's count by query name. We can go in and see that it's reaching out to anonfiles.com and premiumize.com, which these are C2 observed C2 of observed C2 that the Lockbit ransomware has communicated with. So ideally, these should be being blocked by your firewalls, or if they're not, you should go in and block these from your firewalls. So that again is, I'm saying these like it's very matter of fact. We are theorizing that is what these things are, right? We don't know for a fact what it is. We're still going through collecting our logs, doing our investigation. We know that this needs to be elevated to a level that we could probably classify this as an incident of some sort. We add that to the list of what the DNS and network connections are. So with all that, so we know in our little hunt, in our initial triage, we know what processes were created, what the parent images were, what files were created, DNS queries. We're not going to look at the processes terminated right now. What registries were modified, we have a pretty good picture of what is going in here, right? It seems like this somebody downloaded a file that was executed via Explorer, so that requires user interaction. It's in the downloads directory, so we can assume that it was downloaded probably from the internet. You could go in and check if it has the mark of the web in there to kind of verify. That will tell you exactly where it came from. We know that it ran a bunch of discovery commands. It created a shadow shadow copy. It went in and created the shadow copy, tried to pull out the ntds.dit. No, I'm getting confused with the other one. Sorry, it didn't create the shadow copy. It deleted the shadow copies. So it deleted your backups. It went in, it created this compression archive of this lockbit v3 directory, which is our stage directory. So it archived that. We see that that was later sent up to file.io via curl. We know that the event logs have been disabled, so we shouldn't create any new event logs, and we know that the event logs have been cleared. I think it's safe to say that we have observed some malicious activity, and we have enough to be able to pass this on, get the team involved, and get everybody looking at it, right? So we do have some unanswered questions. So if you notice, we did not see the process. We did not see the files being created. We have no indication of how they were encrypted, and well, the registry modifications we did see, and that is because those actions were performed via Upshell, which is or via Upshell or via Windows API, which exists only in memory. So we're not going to see those command line parameters or those command line actions or command line arguments, but we can see again that those state-based detections, we can see that those files were encrypted. We can see that they were modified. They had the .lock bit added to the end of it. We can't see any of the registry modification command line stuff, but we can see that the values of them were set, and that by looking at the D word, which I totally forgot was there, we can see that it was set to 0, effectively disabling those. So that again is the focus on keyword searches are great, and looking at command line arguments are great, but if it's in memory, you're probably not going to see it. But you will be able to see the actions on disk. Most of the stuff has to be written somewhere. You want to focus your detections on those state-based changes. Um, excuse me. And then one question we have there at the bottom is um, why didn't we see the curl? So when we were looking at those DNS requests going out, why didn't we see the curl one going out like we saw in the slides? And the reason for that is because we weren't looking far enough. All that we were looking at here is if the image is h1.exe or parent image is h1.exe. If we change this to image equals curl, we can see that curl went in and went to transfer.sh. So that's what I was talking about earlier, in that you don't want to pigeonhole yourselves into something so small that you miss things, because that can easily be glossed over. You forget that you saw that process creation of it reaching out to file.io, which is great, but if they perform that action in memory and that command line wasn't logged, you wouldn't see it. You'd have no idea, right? So by modifying the search to extend outside of just that parent directory or that parent image or image, by expanding it to account for curl as well, we're able to see additional things that happened around that time period. You could also, instead of having the images in here, you could change the time period to reflect on when this incident occurred, and then that could also kind of give it to you as well. Now I said that we added the easy wins dashboard here. So this is another place you can go to, and we can see some suspicious command line images, registry values, those curl commands again, PowerShell reaching out to some other places, and then the suspicious command line creation. So we could have even seen, just by checking this dashboard every day, it could kick off some additional hunts for you just right off there.
All right. Well, with that, Tyler, we are over time. So let's crush those last few slides real quick.
For sure. Sorry about the time, everybody. So yeah, getting into that, the last part we're going to talk about is reporting. You should have about an hour left on your lab, so you should be able to go into your lab and create these things. But like Secretary James Mattis said, USMC retired, chaos. What do I know? Who needs to know? And what have I told them? My little soapbox. This is so important.
Go
Without
switch your screen.
reporting, snap, crackle, pop. We have a local grocery store by us called Schnooks, and whenever my son wants to say a bad word, he goes, "Oh, Schnooks." I think it's hilarious. Um, okay, yeah. So reporting. What do I know? Who needs to know? Have I told him? Without reporting and dissemination, there will be no long-standing effective changes. Period. If you do not report accurately and thoroughly and give it to the people that need it, nothing is going to change. You might as well have not even done anything. You need to be thorough, specific, state your assumptions. You're not going to be able to see everything. If things are done in memory, if there are some other sneaky ways, maybe the dwell time is super long, you haven't seen everything, maybe you're still piecing it together, that's fine. State your assumptions in there. State what you think is happening and why. And you want to anticipate questions that people will have and answer them ahead of time. You should be able to give a report to someone and they read it without any previous context and they understand what happened and why it's important. That's my soapbox. And to do that, excuse me, to do that, you can utilize the MITRE ATT&CK Navigator. This is super helpful to show from a visual standpoint what is happening in your during your hunt, right? So you're able to map via red, yellow, green, things that happen, things that you think happened. It has a great flow to it. It's easy to read. People understand this lexicon, this terminology. I could not recommend the Attack Navigator more. It's not MITRE bingo. You just map the things that you see on there, and it will help you to kind of to create a better holistic image of what's going on. And then the next up, the actual report piece itself, would recommend the Center for Threat Informed Defense, CTID. They have a lot of authored reports and threat emulations and other things like that that they have on their website. The one we're going to talk about is the intrusion analysis report. Basically, you can go onto their website, which we have in the lab. You guys can go onto the website. It will prompt you with questions to kind of aid in your analysis reporting. You can put parent process, what network connections, file hashes, discovery, descriptions, all kinds of stuff. It's super useful. We used to do intrusion analysis challenges every couple of weeks at my old job, and if I had seen this, I would have 100% had them use it to make their reports. If you don't have a standard incident analysis report, I would use this one. Got the link there at the bottom, and again, it's in the lab with an example for you to go through. And then up next is the MITRE ATT&CK flow. So this is another great way to visualize a more, it's similar to the Navigator, but more in depth. So it gets into exactly what processes were ran, exactly what T codes were being ran, descriptions of what happened. You have to create this yourself, but it's a great way to visualize and articulate what is going on in your hunt, in your analysis. It makes it very easy to read. Very highly recommend. Again, it's in the lab. Which will take us into the lab, but I'm going to go through the next 3 slides real quick. So in the lab, it's going to have you generate that attack navigator intrusion analysis report and the attack flow. We have examples of these on the desktop in one of the folders. I'll look at it here in a minute of ones that I've already filled out, so you don't have to go through and copy paste the same information in there. And then just some quick tips that we have. Again, start with a wide net on your search and then focus in as you get more specific on what's happening, right? You want to start wide, cast that net, get the bait, and then individually kind of hunt and focus in on that afterwards. Take your notes early and often, be thorough, and provide context. You would be amazed at how much you forget what you're seeing when you're looking at IP addresses and hashes and host names. It all can get kind of confusing, right? You need to document often and be thorough. Have it so you can give it to someone can pick up where you left off and understand what's happening. And anticipate questions and provide answers. Think about what somebody would ask you. Think about what people would ask you, what they would have a hard time understanding, what they would want to see. Anticipate that and provide answers for that. The more you hunt, the more you do this reporting, the easier it will be and the better your reporting will be and the better threat hunter you'll be, which ultimately leads to your environment being safer, being more secure. And then hunt as often as you can. Like I said, the only way to do it is to do it, right? You gotta get in there, gotta learn your environment. Even if you don't find the bad guy, the the experience of going through the hunt will just prepare you for instant response. Going through the hunt will familiarize yourself with your environment, with everything that's happening. You'll be able to spot abnormalities so much more quickly and have less questions, and it'll have more definitive statements if you hunt as often as you can. And it's super fun, right? It's like a puzzle, but with repercussions. And then, like Trey had hit on earlier, we have free training pretty much every month. We're taking December off to revamp the labs, but coming in the new year, we have labs. We have purple team engagement, or had to run a purple team, doing purple team exercises, threat engineering, detection engineering, all kinds of stuff. So please check us out at that link over there. And then last thing, we do have a swag shop. So all of our donation, or all of the purchases from the swag shop, go to helping chubby unicorns, also known as rhinos, get some cool shirts like this. Trey's got an old school shirt on. They got hoodies, and my dog isn't in here, but my dog has a bandana because he's always on my couch. So I said, if you're gonna be in here while I'm working, you gotta rep the brand, right? Lots of fun stuff on there. Just a little shout out there. And then, yeah, thank you guys for joining. Sorry for some of the hiccups. Hopefully everything went pretty smoothly. I saw that the must have been the wrong file got uploaded to the resources, so we'll go ahead and shoot. And a lot of people asked for the slides, so I will download the slides and I will make a new CPE, and I will shoot that out to everybody. We have your email addresses when you signed up for the course. So yeah,
Tyler,
thanks again. Yep.
with the CPE, I went ahead and fixed it in the platform. So if they just
Oh,
refresh under resources, they'll have a new one.
okay, awesome. Thank you. Yeah, sorry about that, guys. I'm not sure what happened. That's odd. Um,
We went back to the future with it.
Yeah, back to the future with it. But yeah, thanks everybody for hopping on. We added about 50 more minutes to the lab time. The last part of it just has you go through doing that reporting stuff. Like I said, we have some already filled out examples on the desktop under the should be under like the hunting through the SIEM folder that you can go through. Hopefully everybody got something out of this and had a fun time. Yeah, thanks everybody for hopping on.
Till next time, everyone.